Hello world and hello World Wide Web. In today's video, I have compiled a few hours worth of C# crash course learning where I really summarize C# learning as if we're going into a 200 level course with C#, because that's exactly what my class is currently doing. My class is getting ready for a .NET Core MVC class, and I wanted to create a refresher lesson for them. Now, of course, there's a lot of theory involved, but at Rankin Technical College, we learn by doing, and so I want to focus my lectures more so than ever in the past on doing the coding required for learning. And so you can see the various smaller projects that we will complete throughout this tutorial. And again, kind of the objective here is to crash course C# learning as a review, or if you're coming from another programming language that you've at least coded before in some other language, review the C# language as if there's a 100 level textbook from start to finish in a matter of a few hours. And so I really wanted to take a 100 level course and try and summarize as many concepts as we can. So we cover everything from getting started with Visual Studio, basic data types, of course, if statements and for loops, and working with strings and working with classes and objects, of course, working with lists and working with dictionaries, try catch exception handling. We cover an entire textbook worth of information, primarily focused on writing the code. So a little bit different approach here. As a teacher who's been teaching for a long time, I just want to focus more on doing the work. And let's face it, Rankin is from St. Louis, so the show me state, as they say. So show me your C# in these 9 projects. So hope you enjoy the crash course of learning C#. All right, so what we are going to do is crash course some C# review. Okay, the target audience for my class is students who have been through their first C# class, but they're a little bit removed from their first C# class. And so maybe you took it, a year ago, maybe you took it a semester or whatever ago, but it's been a little while. So we are going to refresh on all the basics from your 100 level course when it comes to C#. Now, in order to do this, I am going to use Visual Studio Community Edition. This is free download on the internet. You can use VS Code if you're on a Mac or Linux computer. However, I will not be demonstrating anything in VS Code. I will be demonstrating C# .NET Core edition from Visual Studio 2022 Community on a Windows PC. So we're going to go here. We're going to click on this download button. It's going to put an installer in your downloads folder. Okay, when you run that installer, an installer is just a piece of software to install more software. So think of Steam, if you will, to install other games. You need Steam. So this Visual Studio installer, I had to update my installer to kind of get it up to date, because my old installer was old. It's like patching Steam or patching the installer. And now my installer is up to date, and I'm going to click on to launch the installer. Wait a minute. No, this is launching VS Community. I'm going to click on modify. When you click on modify on this screen, it actually lets you modify the different software that you have installed. Okay. Now, what we need for this class versus what we need for the demo is 2 different things. In this class, my students should click ASP.NET and web development. Obviously, we're going to need all of these templates. So this is going to download the templates for Visual Studio Community to bring in. But I also want you to select the .NET development because we're going to be working with console applications in this kind of what we're doing here. Okay, so we're going to be writing C# in console apps. Very specific reason for using console apps. Console apps are very quick and easy to demonstrate concepts. Okay, those concepts we bring into real world software, but we learn at the console we learn the concepts at the console because they're easy to demo, easy to use, and then we bring them into real world software with .NET Core. Okay, now it looks like maybe I don't even need anything. It says remove out of support components. All you have to do is check these two boxes and click install. It looks like I've got some out of date stuff that needs to be removed. So let me go ahead and remove my old stuff. Sure. Okay, so let me run through that. Okay, so everything's up to date now for me, it looks like. So I'm going to go ahead and click on launch. This is going to launch my Visual Studio community so that we can go ahead and get started. Okay, so this is my landing screen. You probably see a welcome screen the first time you land here. You can close that welcome screen. It's going to look something like this. Obviously, I've worked with some different things before, so you're probably not going to see all the recent things that I have. But on the right-hand side, getting started, we're going to create a new project. Now, Visual Studio Community, reminder, you have solutions and you have projects, right? Solutions are just the parent for the projects. And so I just think of a solution as a container, and one container that can host many projects. And so that's what we're going to do. We are going to create a solution that is going to have many projects. Now, for my students, okay, where on your hard drive do you do this? Let's talk about that. I'm going to pause the recording because you guys are going to put this on GitHub. Okay, so we're going to walk you through GitHub Classroom. Anyone else can put it anywhere on their computers, but let's talk about getting registered for GitHub Classroom. All right, so I went ahead and I cloned my repo, and this is going to be on my hard drive where I'm going to put my solution. You can basically see this is my desktop. Here's my repository. Here's a labs folder, and here's chapter 01. Again, where you put this on your hard drive is ultimately up to you. Okay, so back in Visual Studio Community, I'm going to create a project. And again, we're going to be learning using console apps. All right, we're going to be learning using console apps. These templates, will change what we select. To find a console app, I want you to filter by C# is your language. That's an important filter because .NET has like other less important languages like F# and VB.NET and all VB and all this kind of stuff. I'm going to choose C# and I'm going to choose desktop. I think we're going to see our console apps.
There was a console.
There is a console one. Thank you. There's console. Okay, so remember .NET Framework is kind of the old, right? .NET Core is the new. So I'm going to just choose console app right here. This is .NET Core, and it doesn't specify Windows, Linux, or Mac, but that's how you know it's .NET Core. All right, now we've selected a console app, and this is going to be where on our hard drive that we're putting it. Paul says, well, hey, should we make a folder, whatever? And again, I'm just going to navigate to my repository, right, as I go through here. Spring 25, here's my all coursework repository. Here's my labs folder. Here's chapter 01. I'm just going to select that folder. Okay, so here's the long path that puts you in my repository, labs, chapter 1. Okay, now the solution name, this will create a subfolder for the container solution. Okay, so I'm going to make my solution name. Now this, to Paul's point, this would make a child folder. Okay, whatever I named this here is a folder that it will create. So I'm just going to put C# crash course.
You need to do the project name first or else it'll override.
well, no, I'm going to do my solution name first, and now I can do a project name accordingly. And I'll just call this project 1. Proj 1. Okay, we'll have Proj 1, Proj 2, Proj 3, so on and so forth. Project, project, whatever. Okay. Super not important, but you know, we'll call it 1, 2, 3, 4. And click next. Now we do have the brand new .NET 9, and we got the .NET 8 long-term support. When it comes to this versioning, they come out with new versions of .NET, I want to say yearly, but maybe it's every second or every third year they come out with a long-term support. You know, enterprise software is typically written on long-term support. Okay, if it's a standard term support, enterprises don't want to write code and then have to change it because it didn't make the long-term support. Okay, so when I typically, you know, if I'm learning something, I'll learn the new stuff with .NET 9. But when I'm writing code for enterprise, I'm typically, you're talking long-term support. Okay, and that's all I'm going to do before I click create. Okay, so let's take a look. When you click create, what we're looking at, obviously this is Hello World. If you didn't know by now, you should learn that any language you're learning, historically speaking, the first thing you do when you're learning a new language is you print Hello World. Doesn't matter the language, doesn't matter the technology, figure out a way to write Hello World. That is the norm, okay? Now, one of the criticisms of C#, and it's, you know, C# was built on Java and C++. So if Java and C++ had a baby in the early 2000s, that baby was C#. So a lot of what it came from was Java and C#, okay? Merged together. The criticisms was there was so much boilerplate code to get up and running that it was overwhelming to learn. It was like, oh my gosh, it needs 50 lines of code just to write Hello World, okay? That quote-unquote problem has been hidden from you here, okay? Even a console app doesn't have 50 lines of code just to say Hello World. It is literally out of the box, is Hello World. Now, I don't necessarily love that. You guys see Solution Explorer? It kind of hides what's referred to as the main method. The main method is kind of the start line where the execution of code starts running, okay, is in the main method. So if you guys have Solution Explorer visible to you, mine was kind of hidden on the right-hand side. It might help for me to reset my window layout. I'm not going to do that right now because I like my window layout because I've done that. But Solution Explorer should be there by default. And in Solution Explorer, I can see my solution, which is the container of my projects. Right now, one solution, one project. And I believe I haven't done this in a while, but if you kind of dig around in this project, you can find the main method, which is not really the point here. The point is let's just click on Start Without Debugging, and it's probably just going to pop open and close really quick. It's the way consoles used to run. And you see build started, build succeeding, and wow, even that problem has been fixed. Okay, so in the old days, Hello World would just flash up and then it would close right away. The console window wouldn't even remain open, but they've even fixed that problem. So there you go. We have now written Hello World. You change what's inside these quotes. This is referred to as a string literal. You can make this any string that you want. Hello class, welcome to 2025. Control S to do that. Now hot reload is this little button right here. I mentioned that yesterday. We'll kind of rebuild and apply. I've never done a hot reload from the console, but it just reruns my console. And I don't have to click on the play button anymore. I think if I click, so Control F5 runs. Okay, there you go. Now we don't have any breakpoints. If I put in a breakpoint here, and I can run this in debugging mode, it would hit my breakpoint and let me do some troubleshooting. Okay, notice here I get this little yellow arrow, and this line of code has not yet executed. Okay, if I just click continue, it'll then execute that line of code, and I get welcome to 2025. Okay, and so that is hello world, and that's a string literal, that's a breakpoint. All right, any introduction of C#? The next logical step is to talk about variables and data types. You guys are not beginners, so you all know that variables are where we store the data. Ultimately, that data is stored in your computer's working memory, referred to as what? What's working memory in your computer? RAM. Volatile memory is referred to as RAM, right? RAM, as I learned in my day when I was playing EverQuest, if I didn't have a lot of RAM, boy, my EverQuest ran pretty slow. Okay, my 64K of RAM needed to be upgraded to 128 for whatever, 196, and boy, did my EverQuest run fast. Okay, when I upgraded my RAM. So if there's a single source of speed on your computer, many times that answer is RAM. Our variables go into RAM. Okay, the more variables, the more RAM utilization. The less variables, the less RAM utilization. Guys like Bill Gates, when he wrote Windows, he used to be concerned with how many variables he had to write and how much space in RAM it took up, because computers did not have much RAM. Nowadays, this is no concern to us. Basically, don't worry about it so much, because we got tons of RAM. Of course, we need to be aware that, you know, at some point, you know, you want to write. Yes, you do want to write efficient code. I'm not saying, but this is not the most important decision that we need to make today. Okay, let's talk about data types in C#. And there are many data types in C#. And so let's kind of go through. Let's go through a byte, a short. These are numeric data types, by the way. Int and long. Okay, so to have a byte, okay, let's even talk about a little bit more. In JavaScript, we just have var, right? JavaScript is referred to as a dynamically typed language. You just say let or const or var, and the JavaScript engine figures out the appropriate data type and assigns it for you. C# is a strictly typed language. Many of you guys were talking about, I just like strictly typed languages, because you know what's going into your variables a little bit based on its type. Okay, you understand the data, the shape of the data, because you understand types. Okay, basically the difference here, you know, this is an 8-bit, this has 8 bits of RAM. Like nothing, literally 1 byte, right? 1 byte, 8 bits, not much, right? They kind of double, 16 bit, okay, 32 bits, and then we got 64 bits. So just basically, okay, why does this matter? This matters because you can store larger and larger numbers in each, okay? If you were to get into binary math, you would see there's a range of values, something like 255 values, which if you do positive and negative numbers, it's something like negative 128 through positive, 127. I might have that backwards. Okay, but you get 255 total possible values, right? So if you wanted to store, the money in your bank account, a byte is a bad data type, right? Because you've got $200 in your bank account, and this can only store numbers up to 127. Okay, so that creates a problem where the data type overflows its allocation of how much data it can store. And so if you try and store the number 200 in a byte, it goes over 128, and then it goes back to the negatives into like negative 128, and it stores like, you know, whatever it is, minus 100. Okay, so the consequence of your data type selection is like the valid range of numbers that they can store. Okay, and they just obviously store more and more. And so the next logical question is, well, why don't I just store everything in a long? Because it has, you know, 64 bits of storage, and binary math tells you that's a really big number. Okay, this is a really large range of numbers. And again, it just comes down to, well, is that the most efficient? Do you need 64 bits? Okay, again, for the most part, it's not the most important thing that we worry about, but we don't want to intentionally be inefficient. Okay, I will say in a lot of cases, you're going to be safe with ints. Okay, ints, I want to say off the top of my head, is like negative 2 billion to positive 2 billion. Okay, so yeah, 2.1 billion, negative and positive. Okay, there are also, now all of these, when I'm saying byte, short, ints, and long, your data types can be signed or unsigned. Okay, so every data type is either signed or unsigned. A signed data type means there's one bit that represents the positive or negative sign. Okay, so a signed data type can be positive and negative. An unsigned data type, you know, like an unsigned or a signed byte. Okay, actually, I think a byte is unsigned, so it's from 0 to 255, excuse me. Okay, so a byte can store positive 0 to 255. A signed byte, this is where you actually have one of those 8 bits for a sign, so you can actually have negative numbers, negative 127 through 128. So it is very uncommon to see, but you have things like S-byte. An S-byte is a valid data type. It's not a common data type, but it is a valid data type where one of the bits is used for a sign. Okay, now integer is signed, the other is unsigned int. Okay, an unsigned int is 0 basically through 4 billion. Positive, because it's unsigned, it can only store positive numbers. So you do come across these occasionally, not very often, but you do come across these signed bytes or unsigned ints that can take the same number of bits and either have a sign or not have a sign. Okay, these are your numeric whole number data types, right? You will notice none of these can store a decimal point. And so the next data types are your floats and your doubles. Okay, floats and doubles are referred to as a category of floating point, meaning they can store decimals, decimal points. This is 32 bits. This is 64 bits, similar to ints and longs. Okay, floats is 32 bits like an int. Doubles are 64 bits, typo 64 bits, golly, 64 bits like your long. In C#, there's also a decimal data type, which is 128 bits. Okay, so the recommendation for monetary values are typically decimal because with money you got to be accurate, and that offers a lot of decimal point precision. Okay, so you don't get some funny Office Space rounding off the pennies errors. For those of you who are fans of the Office Space movie, you'll know what I'm talking about. Okay, so these are our data types. We're coming up on our first little programming challenge where you guys are going to work with some data types. We also have Booleans, which is true or false. And okay, these are referred to as the value types. All of these below are value types. Okay, value types meaning they're stored directly in they're stored in RAM. In one address. In one address in RAM, you can find all of these data types. Okay, so they're basically the way they're stored in RAM. Okay, there's a different data type that is a reference data type, which that goes by a couple of names, but or object data types, right? Reference data types are more complex data types, okay? They're not stored necessarily in one address. Ideally, they're stored in multiple addresses in RAM. And so I think of a value type, you know, if you're thinking of like a neighborhood. A value type, the data can be stored in one house, okay? It's all in one address, okay? In a neighborhood, you've got one address, and it can all be stored in one house of location. Whereas these references, they might be a couple of houses. It might be 2 or 3 memory addresses. Preferably they're contiguous, meaning one after the other. So they might all be on the same street, okay, contiguous memory locations, but they're more complex, so they're not all stored in one place, okay? So a string is one data type. A string, you guys know, is any combination of characters at the keyboard. We do have actual objects themselves. We have arrays. We have things like interfaces, you know, we get into things more advanced like dynamic, and these are not things that we're going to necessarily cover. We got pointer, data type. Okay. The next thing I want to point out, and this is important, and we will come back to this, is that you can mark data types as nullable. Okay, so just like a data type can be signed or unsigned, you can mark a data type. Data types can be marked as nullable. Okay, so when I see something like this, okay, by default, ints do not allow the value of null. Null is a value that represents the void. It represents nothing. It represents, you know, like no data. The data is null. And I will tell you, as we get into MVC, you see this convention a lot, nullable types versus not nullable. So I can actually literally, I can come in here and say equals null, and this is acceptable. If I take that question mark off of the data type, you notice I get the red squiggly. Okay, so all of our data types are optionally nullable. And really that just means, can you put the value of null into it? That's all that means. Okay, now that has some consequences when we start talking about other things, but simply said, our data types can be signed or unsaid, and they can be nullable or not nullable. By default, they are not nullable.
So question mark just makes it unsigned?
The question mark makes it nullable. It allows it to store the value of null. Okay, because right when I don't have that question mark, you can see the red squiggly, that doesn't work. Okay, the value of null, yes. So the question was asked, does changing it to nullable make it a reference type? And the answer is no. Now these are considered value types, but it is worth noting that these have methods. So the integer data type, the lowercase int, has a int32, my int equals new, my int, or int32. Why am I saying this? Let's see if I can get this right. Bada bing. Cut it out. Okay.
For S byte, it's negative 128 to 127.
Yeah, I got that backwards. Thank you, but you get the point. You know, I'm not going to get the numbers perfect, but I'm just getting the concepts across. Thank you for pointing that out. Okay. In languages like Java, this is not true, but C# it is true. So, you know, these value types, we call them value types. And that's because, you know, at some point we're going to start talking about methods and passing by value versus passing by reference. But behind the scenes, this int, lowercase I, is a class. There is a class. There is an alias. It's basically an alias. This int is a shorthand for doing this. And that's provable because if I do my int, which is my identifier dot, I get all of these properties and methods that are part of this variable. Okay, so even though we call them value types, they are in fact objects, which is confusing. Does that make sense? Clear as mud. I just wanted to point this out, that all of our data types, we call them value types, but they are in fact still objects. And as proven by the fact that this is the longhand notation, line 13 and 14 are essentially the same thing. And I can prove it because my int has methods and properties associated with it. Okay, so let's put all this to use a little bit, and let's do a very simple data in, data out. Okay, so console write line, please enter your name. Okay, and console.readLine. Okay, and then I'm going to say console write line. Now this is my JavaScript syntax. That's different in C#. I literally just wrote this. So we are going to store this read line into a variable. So I'm going to say string name equals, and then my write line, I'm going to output my name. Okay, very similar but slightly different in JavaScript. So please enter your name, read line name, hello name. Save, run it. Okay, so here is your challenge as we run this simple program. Please enter your name, Bob. Hello, Bob. Okay, now I want you to ask another question for the user's age, and I want you to append. So here's ask the user for their age, append their age to the write line statement in line 34. Okay, so there's your first challenge, to ask the user for their age and append their age to the write line statement. It should only take 30 seconds. Let me make this slightly more clear. Line 35 should say, hello, Bob, you are 43 years old. That's what the output should say. Okay, as many of you are probably figuring out, it's a little bit easier to do strings than it is to do numbers. You might wind up with a data type mismatch. Okay, so as you're working through this problem, 43 is an int, but notice that this read line, if you hover over read line, can everyone look at my screen? Yes. Look at console.readline, and you could see the return data type from console readline. You could see it is returning a string. The return data type from the readline method is a string. So what we have here is a data type match. We've got a string on the left and we've got a string on the right. That works really nice. But what happens when you put an int on the left and a string on the right? You've got a data type mismatch. Okay, so how do you fix data type mismatches? Of course, you have to convert data types. Okay, so if you're trying to store a string into an int, remember how to convert. Okay, let's go ahead and solve this. Of course, we need an int user age equals, this is the problem that many of you ran into, of course spelling console correctly, is that you got this data type, it says cannot implicitly convert string into an int. You might remember convert to int 32 console.readline. Okay, now with this nice syntax, you put the $sign up front in front of the string. Now remember, there's different versions of this, right? Remember concatenation? Like at first we would always concatenate our strings together, and you'd have to append the variable to the string, and then you'd add another string, then add another variable. And now they call this string interpolation, fun name. but it just means that you can put your variables right in the middle of your strings. They call this like syntax sugar. They just make it easier to write code. You are this many years old. And put your variable right here. And so since I put user age, now if you run that, please enter your name, Bob. Oh, notice that. Interesting. Anybody run into this? Please enter your name, Bob. I hit enter. You need an extra right line. Why? Well, it's let's enter. The solution to this is, if I'm remembering correct, we need to drop an extra console read line in there. Console apps are funny. No. Oh, I need another question. Thank you. Golly. Okay, silly. Let's go. I got you. Console right line. You need to prompt the user. Please enter your age. Sorry, I'm going too fast. And that'll happen. So please enter your name. Bob, please enter your age. 45. Hello, Bob. You are 45 years old. Quick note, of course, I left off chars. Chars. Can't leave out chars. Char stores an individual character. Now, what's unique about chars, to remember about char, is it's a single quote. Okay, so a lot of people want to put chars in double quotes, and that doesn't compile. To enter a char, you need single quotes. So don't forget about the chars. Just checking my notes, I realized I left that out. Okay, so we've covered quite a bit here. We've covered Hello World, we've covered installing Visual Studio, we've covered numeric data types, both whole numbers and floating point. We've covered text-based data types like string and chars. We have converted strings to numbers. We've talked about, again, other data types like Boolean. All right. Wonderful. So after a conversation about data types, any programming language should probably start there. Then you got the basic structures and, you know, things like if statements and loops and switches, and, you know, these are the absolute foundations of programming languages. You should be very highly confident in them by the time, you know, you graduate. These things should be, you know, second nature. But that's where the conversation goes. And so Open Solution Explorer. Now again, right now we've got one solution, one project. Okay, so what I'm going to do is I'm going to add project number 2 to my solution, and we're going to do some different code in project number 2. I can kind of close out of project number 1 in Solution Explorer. Watch how I click. You will need to do this. I'm going to right click on the solution, and I'm going to add a new project. So again, if you right click the project, you can't add a project to a project. You got to right click the solution and add a new project to that solution. In Visual Studio, there's about 5 ways to do the same thing. So I don't care if you do this differently. This is how I do this. I find this to be the easiest way. Now I'm going to add another console app. Again, my recent is up at the top. Okay. And I'm going to say next, and I'm just going to call this Proj 2, where we are going to talk about and review more basics. Things like .NET long-term support is my choice. The for loop. Now, what I have not done is enabled Copilot on this yet. Right, so I'm not getting AI suggestions. I'm just getting what's referred to as IntelliSense. Okay, IntelliSense or code snippets are kind of built into Visual Studio. Copilot, that's, as you guys are familiar, that's referred to as AI, or more specifically, it's a large language model that predicts the next word. LLMs are advanced word predictors. LLMs are also advanced code completion tools. As word predictions, they can complete English very well, and LLMs can also complete code. Okay, this is only IntelliSense. IntelliSense is what's built into Visual Studio. Now, Copilot, I believe, is actually free to the public for Visual Studio Code. I don't know if it's free to the public for Visual Studio Community. This is something we can explore, not for right now. It is, thank you. So I knew it was free. I thought it might be for community. Nonetheless, if I type in the word for, just check this out. You got for loop. If I arrow down to this one and I hit tab, you get a templated code snippet. Okay, so just built into Visual Studio, you type a keyword like the word for or for each, go to the one that says for loop or for each loop, and you hit tab, and you get a code snippet. Okay, so we're going to talk about loops, and we're going to talk about conditionals. Okay, now I've been teaching loops for like 2 decades now, and as we're jokingly saying I'm getting old, that makes it definitely, I've been teaching loops for a long time. The best way that I've found to describe loops is that I say that loops make your program powerful. What do I mean by that? Is you can write a little bit of code and loop over it, and it can do a lot of work. Okay, so utilizing a loop, you can write a little bit of code and do a lot. Okay, conditionals, okay, so write a little bit of code that does something repetitively, as the loop name suggests. Spell check myself, whatever, that does something repetitively and makes your program do a lot of work. Okay, so loops make your programs powerful, whereas conditionals make your programs smart. Okay, it wasn't until conditionals, things like if statements, that as human beings, we make conditional statements all the time. Something to the extent you guys all made conditional decisions this morning. If I want to go to school and be on time when the alarm goes off, I get out of bed. If I want to be on time is true, I get out of bed. Now, you probably do multiple things, right? You get out of bed, you shower, you eat breakfast, you drive, you walk in the classroom, you sit down. Okay, so if one thing is true, you want to be on time to class, you have multiple statements, multiple things that you do, that makes you smart because you're a human being. You can make decisions based on conditions. Humans make decisions based on conditions. Okay, conditionals allow our software to do the same thing. It makes our programs smart. Okay, the other side, if you write the conditional incorrectly, obviously your program is going to be dumb. How smart is your program depends on how you write these conditionals. And so here's a for loop. Now I'm going to tab this over. Now the for loop has 3 parts separated by semicolons. We have what's referred to as the control variable. It controls the number of iterations of the loop, or it plays a role in controlling the number of iterations. Okay, so I is just your identifier. We start I at 0. I less than something. 0 is less than 100, sure. Every time through the loop, let's increment I by 1. Console write line the current value of I is I. And as we run that, now how is this making my program powerful? Again, you write a little bit of code and a lot actually happens. Oh, wait a minute, I'm still running project 1. How do I change that? Very simply, again, multiple ways of doing this. There's a drop-down list right here. Excuse me, where it's right here. Here's project 2. Okay, this changes the startup project. Again, you can right-click it right here and change this as my startup project. Oh gosh.
Last year.
Configure startup project. Here's set as startup project. So you can change it just by right clicking and setting as the startup project. I find it easier to use this, I find it easier to use this drop down menu and just choose my startup project right here. So here's Proj 2. If I click on Start Without Debugging or Control F5, there you can see the execution of a lot based on a little bit of code. Now, this is not an impressive thing, but it is powerful. Okay, again, you write a little, it do a lot. Super foundational to every little bit of coding language I've ever learned. We have a question. Yes, sir. You might say, well, is that the only loop? Of course not. There are other loops. This is oftentimes the for loop is one of the most common. That's the one I use a lot. It is a count controlled loop. I mean, you can see. It is often referred to as a count controlled loop and oh gosh, what's the term? It tests before it iterates. Pre-test loop. I can't believe I'm forgetting the name. What does a pre-test loop mean? A pre-test loop means that it tests if this is true before the body of the loop ever runs. So that just means the condition is tested before the body executes the first iteration of the loop. Iteration. Okay, so why are there many kinds of loops? The for loop is one kind of loop. Well, because they're not all count controlled and they're not all pre-test loops. So there's some different loops. Again, the for loop would be very nice because it's concise. Like all the parts are in one place. You declare and initialize a control variable, right? Declaring it on the left, initializing it on the right. Both parts happen right here. Then you test, then you modify. Okay, those are the three parts of a loop, and those three parts are in every loop. The for loop is beautiful because those three parts are all in one line of code. Okay, you get to these other loops and they're not as nice because those three parts can happen all over your code. They can happen anywhere in the code. For example, we've got a while loop and a do while loop. Okay, so let's do a while loop. So here, int j equals 0, while j is less than 10, console.writeLine the current value of j is, okay, I'm gonna, for the time being, well, I could just run, it can run both loops. Now what's happening here? Everyone's favorite.
Oh, you forgot to increase it.
I forgot to modify my control variable. I forgot to increase my control variable, right? Referred to as the good old infinite loop, right? An infinite loop just goes on. It is the song that doesn't end from Lamb Chops. If you get my reference. Now, how do we fix this? We go J++. IntelliSense was smart enough to tell me I did not modify my control variable. But what I want to point out is declaring and initializing happens on line 12. The testing happens on line 14. And the modification happens on line 17. I want you to imagine real world software. Line 12, this happens. Line 400 is where this happens. And line 600 is where that happens. Okay, it becomes hard to understand what's going on with your loops when your code's all over your code base. You know, these different parts of the loop are all over the place. Okay, again, benefit of the for loop, it's all in one nice condensed place. Okay. But the big difference here, while loop is also a pre-test loop. It's not considered a count-controlled loop, even though to me they seem just about the same. While loops and for loops are pretty doggone similar. Again, I don't use while loops in a lot of cases just because I can use a for loop. They're pretty doggone similar. The one that is not similar is a do while. A do while is a post-test loop. Okay, so these two were considered pre-test. Meaning if J, look at this, if J is 20 less than 10? Nope. So this body will never run. Right? Let me undo this. I'm not sure that I ever showed. Okay. This is now working. It is printing out 0 through 9. That is exactly, what if I wanted to print out the value of 10? I could do less than or equal to, of course. Now it'll print out 0 through 10. Okay, what if I wanted to print out every other number? I can modify my control variable however I want. I can increment J by 2. Right? Notice I'm now going 0, 2, 4, 6, 8, 10. Okay? You can modify your control variable however you want. You can modify it by 2, you can modify it by 10. Okay? Remember, this is shorthand for reassigning J to its current value plus 2. Right? So plus equals is shorthand for adding the current value plus 2. A do while is very different. I'll say int e equals, oh, by the way, it is convention for your control variable to be called I. That's the iterator, I believe, is where I comes from. It's convention to call it I, but it can be whatever you want, as any variable can. Int I equals, or int e equals 100. Do something while e less than 10. Console.writeLine. The current value of e is.
It won't run.
Why won't it run?
Because your set value is greater than your while.
It is, but it's a post-test loop. So how many times will it run?
One.
It'll run once, right? Because our condition is after the body of the loop, right? So you're correct in noticing that, well, 100 is not less than 20, but notice it does still print out the current value of e, because it is a post-test loop, and that's the major difference between a do while and a for loop and a while loop. These are both pre-test, meaning if the condition is false, the body never runs. But a do while, if the condition is false, the body still runs one time. So the question is, in the real world, do you need the body to run once? It guaranteed it's going to run once? Then you might consider a do while. Okay, in the real world, if you know this code block needs to run at least one time or more, there's your answer, is a do while. But if you don't know if it needs to run 0 or many times, so again, 0 or many, you could do while or for loops. But if it needs to be 1 or many, 1 to many, then you're talking about a do while. So that's the big difference there. So let's do a programming challenge specifically with for loops. Okay, I'm going to comment out my other code here. By the way, highlight it, hold down Control, and hit /, and that's how you're going to. That's the keyboard shortcut for this little button right here to comment out your code. Okay, so here's what I want you to do. I want you to print 100, 98, 96. All the way down to 2. Do not print 0. So I want you to print the even numbers from 100 down to 2. Do not print 0 in a for loop. Using a for loop, print those numbers. Anyone care to offer a solution? How do I change things up? Yeah, Paul. Okay.
And then I is greater than 1.
Okay.
And then
Okay. For I equals 100, I greater than 1, decrement by 2 each time. Problem solved. Okay. One more, or are we good on loops? One more. One more challenge. Print odd numbers. Let me think. Okay, here's what we'll do. Start at 100, go down to 50, down to 25, down to 12, 6. If you want to include the decimals, you can, but obviously I think that's going to be a little too obvious, but that's the challenge. Alternatively, you could probably figure this one out. How do you include the decimals? How do you get 25 cut in half is actually 12.5. Cut in half is 625, so on and so forth.
So what's the challenge?
Well, it's just you could do either way. So you basically start at 100, get it down to 15625 and include the decimals, or not. You can get 100, 50, 25, 12, 6, 3. Okay, so either way, including the decimals or not including the decimals. Let's go with the first condition. How do we get this? Where it goes from 100, 50, 25. What is our solution there? Let me get my code back on the screen that it was. This is what our for loop was. How do we get it to here? And Liam.
I divided by equals 2.
Yeah, so that's just changing that minus to divide. Okay, that's going to get the whole numbers. How do we get the decimals? Change its data type to something that accepts decimals. Okay? Now, there's another loop called a for each loop. Okay, and if I look at the code snippet for a for each, a couple things here. We got the keyword var, and we have in. Okay, so we need some sort of either array, some sort of list to iterate over. Okay, so a for each, when we talk about arrays, we'll come back to for eaches a little bit. But at this point, it's also worth noting, as we already had our discussion around data types, is that C# does have a very JavaScript-ish var, okay, where the C# interpreter will interpret your data type. My convention around var is if you know the data type, you should specify a data type, but in the world of the internet, and you're sending data across, the World Wide Web, a lot of times you're receiving data and you just don't know. Okay, that's the reality of the internet, is that you might not know the structure of your data. So var is pretty much necessary in the days of today, right? So sometimes you don't know the data type, and if you don't know the data type, that's where var comes into hand. That's where you can use var. Now conditionals, of course, we have the if statement and tab that in. So the if statement, if something is true, today is my birthday and I am 40 years old, and if my age is less than 50, console.writeLine, you are not over the hill. I don't know what the right answer is. Are you over the hill at 40 or 50? think the answer is 50.
I don't know, you're the oldest one here.
45. I'm actually 69.
There is interesting. Okay. So
I know I've aged very well.
there is no, as you're going through this, do you have to have an else? I think beginner programmers think that else is a required state. There's no else requirement to an if statement. You could simply do something in the event that something is true. In the event that it's not true, you can do nothing. Okay? So beginner programmers need to remember that there is no required if statement.
That is something you forget a lot.
Yeah, else, but if there is something to do in the case that this is false, maybe you want to print out you are over the hill. Okay, so you're going to get one or the other. You're not over the hill, but if I change my age to 400, you are over the hill. Okay, so if statements, just, that's the first thing to remember. Now, the reality is the world is complex, and you're not, in real world software, faced with simple problems like this, just saying, are you over or under? I guess in the age of the internet, you need to check for 21 so you can buy alcohol, but, probably that needs to be done with more than just an if statement. You probably need to look at an ID. You probably need to have some checks and balances there. Okay. The real world is like, if there's a person in front of the car, you don't drive the car. Well, what if there's ice? Well, what if there's a million factors that can determine, does the car go forward or does the car stop? You know what I mean? The real world is full of complex scenarios, and the way that these complex scenarios can be handled are with more complex if-else blocks. And so a common thing is like, if this is true, do this. Else if this is true, do this. Else if this is true, do this. Else if nothing above is true, do that. So a common example here would be like test score equals 50. Okay, now when you have a more complex structure than just if else, the order of operations matter. What if I were to say if test score is less than let's say if test score is greater than 50, this doesn't make any sense obviously, but counsel, right line, you got an F. Obviously the order here kind of matters, and if my 51, what if I were to get a 90? Well, my test score over 50, well, that is true. It would print out you've got an F. So, in the event of this, right, you would start with something like, if your test score is greater than 90, you got an A. Else if test score greater than 80, also if test score is going to counsel right line, you got a C. Else so when you have a block like this, the way I say it is that there's only one way through the woods. Only one of these is going to run. You're not going to get multiple of these to run unless it happens to be in a loop and test score is changing every iteration of the loop. Okay, but on a single iteration of this block, you're only getting one of these to run. There's only one way through the forest. And so what you see in computer science is decision trees, but you're only going through that decision tree one way. Now, because of this, I got a B. Why? Well, it's not greater than or equal to 90. A greater than or equal to 90, right? If a 90 should be an A, you need greater than or equal to here. Okay, and that effectively changes this 90. Okay, so when you have these scenarios, you need to test the boundary numbers. In this case, the boundary number is what you have coded in right here. So you want to test the number itself, you want to test one above, and you want to test one below. Okay, so when it comes to testing your software to make sure that it's matching the real world, right? These are considered boundary numbers, and you want to test the values themselves. You want to test, in this case, you want to test 90, you want to test 91, and you want to test 89. Okay, same thing here. 81, 80, and 79, 71, 70, and 69, and then you want to test anything else. Okay, so greater than or equal to 80, greater than or equal to 70. So if you get a 50, okay, you got enough. Okay. Okay, so this is running code conditionally. This is making our program smart. You basically have conditions that run code true or false, pretty simple. Another structure that can do a similar thing is a switch. Now, interestingly enough, I just hit tab there. I didn't see switch on variable. So let's do int age equals 3. Switch on age. Case 1, break. Case 2, break. Case 3, break, and default. Okay, you don't need a... Okay, so this is kind of the snippet that should kind of exist for a switch. Or maybe that's more than a snippet. So console.writeLine, if you're 1, you are an infant. Case 2, you are a toddler. Case 3, you are a young child. And default, I don't know how old you are. And break. Okay. So where are switches useful versus like ifs and if else's? Okay. Historically, there's a big difference between ifs and switches. Notice a switch is a single value. I'm not testing for a range of values. Okay, so something like, are you greater than 90? That's a range. That's a whole bunch of numbers that are greater than 90. Switches can't do that historically. Now that changed, okay? At some point now, and case, I don't even know the syntax. Okay, looks like maybe something like this. You can do this now. That used to not be the case. So this is still strange to me. I haven't done this because if I need a range, I use ifs. Okay, I'm just giving you, again, a little bit of the history. Is it used to be true that you could only do this. Single values on your switches. Okay, of course, in this case, I would expect you are a young child to execute. And there you go. And if I change the age to 40, I would expect I don't know how old you are. Okay? So, I don't know. Let's see if a case greater than 10. Let's see if this works. Because I'm not used to that syntax. It says you are an infant. Yeah.
It looks like your console is insulting us. It's like you got an F, you are an infant.
Yeah. You got an F, you are an infant. So it did change somewhere along the way. The cases can do ranges. So in this case, But if you do like an older language like C++, you can't do ranges in C++ or Java. These older languages, you cannot do this with switches. Some people like the condensed syntax of a switch. I would agree that this, I slightly prefer switches syntax over this.
I love switches.
Now what does the break do? Well, a break in C# is actually a requirement. You have to have breaks. In other languages, you don't have to have breaks. Breaks stop what are called fall-throughs. Fall-throughs where you can execute multiple cases. Okay, multiple cases can be true if it falls through, but breaks, this doesn't allow it. Like in other words, you're only running one of these. You're not running multiple. So in other languages, you can actually fall through, and that can be used in different ways. But in C#, you cannot fall through. Okay, this is going to be the first, maybe more significant exercise, okay? All the exercises up till now have just been kind of slightly gimmicky exercises. There is a traditional, there is a traditional programming challenge that companies give because companies are busy. And I'll just say this is an old thing, so I don't know if companies do it as much anymore. But like they want to test your basics. Do you understand the basics? You've probably heard of Fizz, Buzz.
Yep.
Okay, this is the classic programming challenge that I'll use ChatGPT to explain Fizz, Buzz. Okay. FizzBug Programming Challenge is a simple and classic coding exercise often used in technical interviews as a beginner's introduction to programming. The task is as follows. Write a program that prints the numbers 1 up until a given number, so 1 to n, where n is the upper limit. Numbers divisible by 3, print Fizz. Numbers divisible by 5, print Buzz instead of the number. For numbers divisible by 3 and 5, print Fizz Buzz instead of the number. So notice 1, 2, Fizz, 4, Buzz, Buzz instead of 5, Fizz instead of 6, 7, 8, Fizz instead of 9, divisible by 3, Buzz divisible by 10, all the way up to 15, which is Fizz Buzz. Okay? So you are replacing the number with a word in these conditions. So I'll keep this in the comments on my screen. This is essentially now I would expect this to take 5 or 10 minutes or something. The other ones you could do kind of quick, take a minute and do this one. This is going to be what you're turning in. So far, to be clear, those of you turning in, work for me. This first one is just, printing out your name and your age. The second thing you're turning in for me is FizzBuzz. Any volunteers to solve it? Sir, Carter. President Carter. For loop. I is equal to 1. Less than or equal to 15. Now, I would state by saying, write a program that prints the numbers from 1 to n, where n is the upper limit. So you have to ask the user for an upper limit. Okay, so let's ask the user for an upper limit. So I'll start by just tweaking what console.writeLine. What is the upper limit of our FizzBuzz? Okay. And int upper limit equals convert 2 and 32, read the line, and now I'm going to loop less than or equal to upper limit. You with me there? Okay, and then what is the third part?
Third part is just keep saying.
Okay. Yep.
Then I did if statement, and I did I and
Yep.
get the residual
Yep.
of the division, and I did 3
Yep.
equal 0.
Okay.
And
Yep.
2
Yep.
and then I did the same thing. I the residual division 5 equal 0.
Yep.
And I did constant inside there, red line, big buzz.
Yep.
I did a if statement. I used the exact same.
You did another if statement.
Else if statement.
Else if statement. Very good. Let me.
It does.
Yep.
I used the I residual division 3 equal 0. Constant right line Fizz.
Okay.
Then I did else if. The residual 5, of course, is buzz.
Okay.
And then else, constant right line. Installation,
Yep. Very good.
I.
Okay. So again, the beginners level programming tests. Let's run it. Now, right, so the difference here, we didn't talk about modulus. Modulus is the remainder. So this says, if you divide 3 by 0 and the remainder is 0. If you divide I by 3 and the remainder is 0, and you divide I by 5 and the remainder is 0, and if I were to say 50, we get 1 through 50. And if it's divisible by 3, you get Fizz. Divisible by 5 is Buzz. 15 is Fizz Buzz. 30 is Fizz Buzz. 45 is Fizz Buzz. And we have solved for Fizz Buzz. So after this second challenge, we're just going back into a little bit of theory. So take your notes how you want. I'm going to take some notes right on top of this challenge. Now you turn this challenge in, and if you modify it, as long as you have the working solution, if you have anything modification, that's fine too. Okay, so the one thing I want to talk about next is a conditional operator. Okay, so I skipped this a little bit when we were talking about if statements. The conditional operator is a shorthand for an if-else. Okay, so it looks something like this. Int I equals 100. So you say I is I less than 200 question mark. If it is, console right line, this is the true block, I less than 200. Otherwise, and you need a semicolon there, or do you? I guess not. Otherwise, console right line, I is greater or equal to 200.
I remember using this a lot in React.
Yeah, you've seen this in React, and if that's true, and maybe I need another semicolon there. Let me get my syntax right. Oh, my syntax is off by a character or two. Actually, I made a different mistake. If you look at the actual error, it says only assignment, call, increment, decrement, and new object expression. Okay, so here's what we can do. String result equals null. And so we'll say result equals, we have to do an assignment. Otherwise, result equals. And now I'll get my syntax. I'm getting closer. Guys, I'm making a syntax mistake. It's a here. We can simplify it to this. There she is. We do the assignment this way. Okay, so string result equals, is I less than 200? Question mark. If it's true, you get this. If it's false, you get that. I was trying to, again, syntax was off, no big deal. But this is often referred to as the ternary conditional, conditional operator. An operator is anything like a plus, a minus, an equals, any operator, any symbol. Think of an operator as a symbol. So we have unary, which is I++. So I++. We have binary operators. Unary operators operate on one thing. So I is going up by 1. That's a unary operator. Binary operator has 2. So you say like the plus operator operates on 2 things. You get I on one side, you got 3 on the other. So unary operators just kind of have 1 input. Binary operators have 2 inputs, one on both sides. Ternary kind of have 3 parts. You got the
conditional.
The conditional is I less than or equal to 200. You got the true side and you got the false side. So you got unary operators, binary operators, and ternary operators. Is there another way to do it besides the colon? Is the question. Not that's coming to mind. This is the syntax, that works. So and I like the comment that was made is we did this a lot in React, this shorthand if-else notation. And I was like, oh yeah, we just did that a ton, like a month ago. So you guys are familiar, which is good. Okay. Then we get formatting of numbers. Okay, so we get this I, and you might want that number to look a certain kind of way. And so let's hit the docs for this. Okay, so let's hit C#, number formats. Now, these are, C# is maintained by Microsoft, so it is a good thing to learn. This is right on Microsoft's website. These are the official docs of C#. Okay, so it turns out you can format a number as currency, right? If you want it to look like currency, okay, it's going to have the $sign. It's going to have commas where commas belong. It's going to have 2 decimals. Okay, so to format something as currency, you could format it as a decimal, scientific notation, fixed point. So how do you do this here? So right now our FizzBuzz problem, we're not really using this, so I'll comment this out. Right now our I is not formatted any kind of way. But if you do like I believe, oh man.
Either inside or outside the bracket.
When you don't do it every day, you forget the syntax. Okay. So now our numbers are formatted as currency. Beautiful. Right? And that's just :C, capital or lowercase, a real currency value. Now, fixed point allows you to specify a number of digits. But before we jump around, let's go to decimal. So again, you can use this. This is essentially a toString. You're taking a integer value and converting it to a string. That's kind of obviously happening behind the scenes, right? How do I know that? Because an integer cannot store a $sign. An integer cannot store a comma, right? So we're taking I, we're converting it to a string so that we can add the $signs and the commas. So let's just do :D and see. Well, there really are no decimals here. So let's say fix 0.2. That forces the decimal, right? So it will put 2 places of decimals even. Now what if I do, so fix 0.2, what if I do D2? A little bit of experimentation here. Not so much. So decimals, if they're there, obviously it'll put them on there. But if they're not there, it's just not going to put it. That's useful. But if you want to force it to have 3 places of precision, okay, so you can kind of see the difference between decimals, put them there if they're there, if not, and the F is kind of forcing it, regardless of a number being there or not. Okay, we shouldn't have to use exponents too often. I know you guys love exponents from your math classes. We kind of already went through fixed point. Boy, if you want to specify a number to look like it looks in a certain culture, never had to do that, but as you travel, you're going to see that numbers and currencies, they can take all sorts of formats. Not that I've traveled the world, but I believe that's the case. Percent is useful. Percent is useful. Let's just say double n equals. Now I want to show this off. Float n. What's wrong with this problem? You guys have seen this problem before? Float n equals 0.12. Wait a minute. Floats can store decimals, and I put a decimal in a float. That should work. Hover over the error. It tells you the fix. What we have here is referred to as a floating point literal. So remember, there's a category of numbers called floating point numbers. And floating point numbers are anything with decimal places. Then there's the more specific float data type. Okay, so float is a floating point number. Decimal and double are floating point numbers. So the interpreter has to look at this 0.12 on the right, and it has to infer a data type. It has to choose one. It has to choose a data type. Well, the interpreter, when it sees a decimal, it automatically chooses a double. So on the right we have a double, and on the left we have a float. On the right we have a double because that's what the interpreter assigns automatically. On the left we have a float. If you go back to our data type talk, that's like sticking a large object in a small container. It might not fit. Sticking a large number in a smaller container might be problematic. Okay? So if we had some really large number here, that might not store well in a float. Okay, so what they want you to do, even in this example, is they want you to say, I know what I'm doing. I'm going to convert this 0.12 into a float. So even if you're sticking some large number, even if you're sticking some, you're kind of implicitly saying, I know what I'm doing here. Okay, and if I might be trying to stick a large number in a small container, and that's okay. You're essentially doing the conversion here. So in order to do that, okay, that's a floating point literal. That's the solution to that. Where did I leave off here? I'm just going to delete my notes because they're not super important at this point. We were converting between data type. Oh, percents. Okay. So let's do float n equals 0.12f. Console.writeLine. Okay, so let's just print out n. We're going to see the results here. Of course, we're just input output 0.12. Well, 0.12 equals 12%, right? That's obviously the case. So if I do n:p, it's going to take that 0.12 and make it look very pretty, like a percentage that a user would expect to see. Like you guys don't expect your grades to be 0.86. You expect to see 86%, right? formatting the numbers in percentages. Now, I don't know why this is not jumping out of me, but there you go, 12% with no decimals, right? Okay, so that's conditional operators, that's formatting. Again, your syntax may vary. Going back to the docs, there's multiple ways to do this. A lot of times just doing a toString. So if you have an int dot toString, let me go back. I'm showing another syntax for doing this. So this is one syntax for doing this. Here's another. Console, write line. If I'm doing a different syntax, I might say the value is plus n dot toString and then in %0. Okay, this is kind of the older syntax for taking a floating point, converting it to a string, and then specifying your format in those same results. Okay, and as the I got one more thing to cover, and then I'm gonna give you guys a challenge, and that'll kind of wind up the class. I could tell you guys are ready for a little bit something else. I'm gonna point out a problem here. If I'm asking for a number, but the user gives me a letter, meh. Right? Anyone remember the solution to this problem?
Like a catch throw exception or something like
You're barking up the right tree.
that?
TryParse. TryParse. Yeah, try catch is one way, but there is a TryParse, and it'll do this. Okay, so we're trying to convert to an int. So here is TryParse. TryParse console dot readline out upper limit. Okay, now hold on. This is the syntax. Int upper limit is going to be like this, equals 0, and then here we're going to assign it. We don't need actually this. Excuse me. There we go. Okay. Here's the syntax for this. We defined upper limit. We started off at 0. We asked the user for the upper limit. And here, this out keyword, we're going to review this in a little bit, or we'll come back to the out keyword. We try to parse the read line. Parse is another word for convert. We try to convert the string into an int. If it works, it puts the int in this variable upper limit. Otherwise, it actually assigns the upper limit to 0. Like, for example, I could do this 100. Let's check this out. It doesn't matter. What is the upper limit? I'll say 200. Look, it loops through 200. So if I put in an int, it works. If I put in an int, it works. If I put in a letter now, it doesn't crash my program. Instead, it converts upper limit to 0. The way TryParse works, if it works, it does a conversion. Otherwise, it just makes the value of 0. Well, if upper limit is 0, our for loop never runs. Okay, so TryParse is a nice syntax for accepting console input without causing it to crash. Not that we're writing console apps, but it is something that you see pretty conventionally here and there in this world. Okay, one more. We'll call it challenge 3. Give me a second. I just like ChatGPT because it's going to write the challenges for me. Okay, so there's probably going to be a little bit of formatting involved with this, and it's not as easy as it may appear. So let's create a new project. We got project 1, project 2. So I'm going to right-click the solution, add a new project, console app, proj 3. And Again, I think there's different levels that you can do this as far as difficulty. I'm going to put these instructions, and these might not be the most. This is not going to be so specific on how I want this to look. Multiplication table. So the challenge is around a multiplication table. So challenge 1 is storing user data. Project 2 is Fizzbuzz. Project 3. Okay, multiplication table. Prompt the user for number of rows. Prompt the user for number of columns. Display multiplication from rows by columns. If you want an example of what your program could look like, okay, here's a sample program. Now, again, there's a lot of formatting in here that you don't necessarily need. I will point this to your attention. This first row going across, not exactly necessary. This first column, not necessarily. Actually, what you see in here is the multiplication table. If you delete the first row and you delete the first column, this problem gets a lot easier. Okay? But if you want the first row and you want this, like all these dashes, and you want this first column, this problem's a little bit more complex. The problem is written does not require the first row or the first column. It just requires the innards of the multiplication table. And so, you know, solve this at your own. There's an easier way and a harder way. You can solve it either way. I just want the multiplication table. Okay, so I'll pause here and let you guys work. Okay, so here we are the next day, and we're going to answer one answer of this multiplication table problem that we left off with yesterday. Again, if you haven't solved it yet and you're watching this in the future, you can feel free to pause and continue to work. And I think, again, I explained this yesterday, but there's, you know, various levels of difficulty. You could simply do a multiplication table with no formatting. Or you can really put some effort into the formatting of this table. Now, you might ask yourself, why, Mr. G, should I spend so much time working on the formatting? Like, is there a real-world scenario where command line formatting is applicable? Like, where you spend all this time to format something in a terminal window, you know, kind of thing. And I would say the closest scenario that is real world, and even though paper receipts are going away, I think of paper receipts as the closest answer to that question of, hey, I've got this little window of space, and I need to format it to look attractive for the end user. You know, we all have seen paper receipts, and they need to be formatted, you know, right aligned and with currency formats and all this kind of thing. So there are real world scenarios where particular attention to formatting can be important. Okay, so this was we call this project 3 yesterday, I believe. Okay, so how I would begin to answer this, and I've done this ahead of time. Okay, and you guys can feel free to code what I have or give your own answer here. Again, I'm not super picky. As long as you give me a multiplication table, I'm fine. And this is all stuff that we've kind of learned so far using the different tools. You know, I'm using some do-while loops here because I know that at least we're going to ask the question one time. So let's put it in a do-while, and how many rows should you have? And now I've got two integers in a Boolean variable, one for rows, one for calls. This is going to continue to loop while is valid is set to false. So the beautiful thing about a TryParse, and TryParse not only puts the value of what the user typed if it's a number, it'll put it in rows. If not, it'll put it as a 0. But TryParse, if you look at the documentation, also returns true or false. So this method, if I hover it, you could see in the signature the return data type. Can everyone see my mouse? It says bool int.tryparse. That means TryParse returns a Boolean value, true or false. So I could put that in a TryParse and say, hey, while this thing returns false, essentially, continue to ask the question. Okay, so if I just spin this up, this is simply getting the input for the rows and columns to kind of start.
Mr. Chair.
Yeah. Do I need to share my screen? Yes, I
No,
do.
you're sharing.
Oh, yeah. Question.
Want me to let you know that?
Okay, so just demoing what this is, of course, if I type in the letter A, it should prompt me again for the number of rows. So it's not crashing the program. Until I give it a valid, then it'll ask for something here. So at least the TryParse, this is getting to a point where it continually asks me until I give it a good number of inputs. Okay? Then, what does my for loop look like? Well, there's actually two for loops. Okay, so the challenge here, is the first thing you have to realize is you need to multiply the row times the column, right? In order to multiply the row times the column, we're going to utilize nested for loops. And in order to have nested for loop, of course, is one loop inside of another. That's going to allow us to have a different number for the row and a different number for the column. You're going to see we're going to start the row off at 0. We're going to iterate while that row is less than or equal to the user input. Remember, rows is the user input. And then we're going to increment row by 1. So that's our outer for loop. And then we have an inner for loop. That inner for loop looks like that. Okay. Now I am going to start the column at 1, and I'll kind of get to why I started row at 0 and I started column at 1. But we're going to do the same thing. We're going to loop this inner loop, starting at 1 though, while 1 is less than or equal to the number of user input, and then we're going to increment 1 column at a time. Okay. Additionally, I'm going to do one thing. If the row is 0, I'm going to do one thing. I'm going to do something specifically if it's the 0 row, because I really don't need to multiply anything times 0. I just need a little bit of formatting there. Else, I'm going to do something else. Okay, so actually what I have in here is this inner loop belongs in my else. Okay, so we've got an outer loop, and then we've got an if. Actually, I have this for loop actually in both places. Okay. So notice this loop, this for loop, this inner for loop. Now again, here's the takeaway I want you guys to have. There are many answers to this question. This is one answer. You don't have to do exactly what I do, but nonetheless, we've got a for loop, an outer loop, and an inner loop. And this inner loop does one thing if it's row 0, and the inner loop is going to do something else for all the other rows, for row 1, 2, 3, and 4, and so forth. So if it's row 0, and then we loop through the calls, notice here we're not doing any multiplication on this. In this, if the row is 0, we're not doing any multiplication here. Really, this is just a formatting. I kind of don't want to focus on this if statement right now. I'll come back to this. Okay. I don't want to worry about if it's row 0. Let's talk about everything else where we're going to actually be doing some multiplication. Okay, so if, on this where we're printing each row, here's what we're doing. Okay, so now walking through this, we know row is 1 and we know column is 1. Okay, so the first time through the loop. Now these nested for loops, they work like a clock. Okay, so essentially in this case, row represents the minutes and column represents the seconds. So the seconds are going to iterate all the way through before the outer loop iterates and changes the minutes or changes the row. Okay, so this inner for loop will terminate. It'll go all the way through termination before changing the outer loop, which is the row. So again, think of rows as the minutes, think of calls as the second. So this is going to be row 1 times 1. So this is going to output 1 times 1. Of course, it's 1. This comma 6 is the formatting. It is right aligning that number 1, that multiplication of 1 times 1. It is right aligning it kind of 6 spaces over. It's adding 5 blank spaces to the left. And then we have another space here followed by the pipe symbol. Okay, now notice this is doing a console.write. Obviously the difference between write and write line, write does not cause a line break, write lines do cause a line break. So notice these particular, this is going to say row 1 followed by, right alignment and a pipe symbol followed by all of the multiplication for that row. So it's going to be 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, 1 times 6 for as many columns as there are. Okay, then we go to row 2 and we get 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. Then we go to row 3 and we get 3 times 1, 3 times 2, 3 times 3, 3 times 4. Okay, so this is the crux of the problem. Okay, and I think it should be in a runnable state. And if I say 6 rows and 7 columns, okay, we get our 6 rows and we get our 7 columns and we get our multiplication table. Okay, now we've got this, what I would call of the header row, and I've got the these are just the headers, if you will. Okay, and somewhat solve the problem there. But again, kind of taking it back here, you're going to notice that little line there. Which is why if it's row 0, I'm going to draw that line. Okay, so if it's row 0, I'm going to draw that line. And that's going to look something like this. So again, the problem's pretty well solved. The rest of this is just a little bit of formatting. And so here I'm just putting some blank spaces followed by a pipe. So that's going to be just an empty space. We got an inner loop. We're looping through our columns and putting a number there for the column. And then here is basically we're writing a bunch of dashes. Okay, well, how many dashes? 8 times the number of columns plus 1. So that was just the math needed to figure out to get that dashes, the number of dashes correct. And so it's doing a couple of things here. If I kind of run it in its current state and I say 4 and 3, okay, we've got 4 rows and I've got 3 columns. There's that empty spacing that I was referring to. There's the line that is however long that it needs to be. That's kind of a dynamic length line, right? This dynamically length line, this is this little math right here that was just what I would describe as trial and error to figure out to get that to get that to be the appropriate length for that table. Okay, now if we put in some really large numbers, obviously that doesn't work. It all falls apart. But this, so that's more of a limitation, I would argue, of the terminal window itself not being very wide. So this works well up until you get some large numbers. And so how do you fix that? Well, you don't allow someone to type in 50 and 50 and make that acceptable. If you really want to fix that, there are ways about it. Okay, so for those of you who are kind of following my answer, I'll kind of scroll out just a little bit and get this condensed down. Okay, there's kind of a complete solution for the multiplication problem. All right, now moving on. Okay, so this is what we were calling exercise 3. I'll save and close that down. I will spin up now a project 4. We're going to talk a little bit more about strings. Okay, now strings in C#. String name equals Bob. String name equals Bob. Okay, name 2. Kind of start here. Let me zoom in. Lowercase s or capital S, does it make a difference? The short answer is no. They are equivalent. String name 3 equals new string Bob. Kind of another way of writing string objects. Again, strings are reference types versus a value type. Yeah. There's no difference. Yeah, there's no difference between the lowercase and capital. The reason I even bring this up is because other languages, this doesn't work. Like, there is a difference in other languages between lowercase string and capital string. Particularly, I'm thinking of Java. You can't do line 1, okay? Now, in other languages, for example, capital B-O-B, you might agree that name and name 3 have the same value, right? That's pretty simple to see. So then we need to check to see if name double equals name 3. Again, this is handled differently in different languages. I would counsel right line, names are equal, else, names not equal. So when you have reference data types, I would say that this is considered bad practice to compare strings using the double equal sign. Again, why is that bad practice? Because that's in Java, particularly. In other languages, this is considered a big no-no. Let me change this to proj 4. Boot this up. Now, in C#, it actually passes the muster. Still don't love it. Okay, still don't love it. You would expect this in other languages. This does not happen. So I just avoid it. Why do I avoid it? Because there's another way. Remember, these objects have methods. Okay, and you could do something like this. Now, name.equals, we're still testing that. Equals is going to return true or false. And now there's something called like a deep comparison, where you're testing the values in a shallow comparison. Historically, the double equals does a shallow comparison. The dot equals does a deep comparison. But obviously you could saw the double equals does do a deep comparison. And a deep comparison is where you're comparing values. Okay, but what makes the dot equals method even better dot equals, well, if I could spell right. As you can chain methods. If I can spell, come on now. Okay, name dot to lower. So if name dot to lower equals name 2 dot to lower. So we can do things with method chaining to lowercase the names and test their equality. Now I guess you could still do that with a double equal sign, but just method chaining I think makes it useful. I like method chaining. So you might not, now name does not equal name 2 unless you to lower them. So as you might expect, the names are equal, but if you get rid of the to lower, right? So the capital Bob versus the lowercase Bob names are not equal. So method chaining is useful there. And so, you know, again, it works, obviously, as I demonstrated, it can work either way, but I have a slight preference, and that's just my personal preference. You can do as you will. It's also nice is that you can, we talked about the for each loop, and you can treat a name as a collection. So this will iterate over each letter. Council.WriteLine or item. Right? So we can break a string up into its individual characters and for each over a string, which is a useful tool. And you don't have to use a for each. You could use a for loop or what have you. And if you want to write it differently, I believe you could say car letter in name. Okay, and be a little bit more specific there. Okay, so this is another kind of common thing to do in programming interviews, like Interviews 101. Hey, why don't you go ahead and reverse a string? Well, how might you reverse a string? And let's do that. So here's a quick challenge this morning to get you guys going. Let's reverse the string. Okay, so I want you to print out NAVE, and that'll be a quick one. All right, we're going to go with Tim's solution. What you got, Tim?
Okay, so I got the string obviously, and then I got a for loop.
For loop, so I'm going to use a for loop.
Yes, I have int I equals name.length.
We're going to equal to name.length, which is 4. We're going to loop 4. Okay, what's next?
-1 after name.length.
Name.length. Why do we minus 1, Tim?
I know why it's important.
Okay, that's okay. What else you got?
And then I is more than or equal to 0.
Greater than or equal to 0.
And then I minus.
And then I minus minus. And then what do you got?
Console.write name index I.
Name index I. Okay, so we are starting our control variable off at 4 minus 1. So we're starting it off at 3. Why are we starting it off at 3? Well, we are going to loop 0, 1, 2, 3. Or we're actually going to go 3, 2, 1, 0. Right? So this loop will iterate 3, 2, 1, 0. That's what I will be. Why is that important? Well, N is index 3. A is 2, V is 1, and E is 0. So name sub 3, name sub 2, name sub 1, name sub 0, and we have solved the problem. Very good. That is the answer for what we are going to call exercise 4. So let me update the lab. Let's continue with project 5. We're still talking about strings. And next up, I want to talk about is null or empty. And do one more string exercise. A beautiful method. So this is if name dot is null or okay, I just made a mistake. Is null or empty is not what's referred to as an instance method. Okay, name is an instance of the string class. So when I say name dot is null, that is referred to an instance method. There are other methods that are static methods. So if I do string is null or empty, these are referred to as static methods. They're just called differently. Okay, instance methods belong to the instance variable. In this case, name and name2 are referred to as instance variables. They're instances of a class. Is null or empty, again, is referred to as a static method, meaning you call it by the class name dot method name. Okay, so again, I just want to highlight there are instance methods that are called by identifier dot method name, and then static methods are called by class name dot method name. Cool? Okay, so I was trying to call this method as an instance method incorrectly. It is a static method. Why is this? Please try again. Actually, how about do while name string dot is old null or empty name console dot write line enter your name. Okay, now, okay, it even tells you with the green squiggly is it could be null or empty. Okay, so we're going to solve that problem by continuing to loop while the user does not give you the input that you want. So as long as the user is typing in empty, you can't. As soon as they give you the name, problem solved. Okay, and it also obviously checks against null values. So I don't know if you started it off at null as we did, you know, and it somehow maybe readline somehow returns a null, or it's great because you want those like falsy values. You know, you want like anything that typically can be considered falsy to be checked against. So here we're checking against both null, which is, you know, one kind of way that data can be empty, or an empty string, which is name2, right? So if I change name2, we got name2 is an empty string, but we're already. Check that out, right? It's actually not accepting. Oh, because I got to change name2. I'm like, wait a minute, it should accept numbers. Okay, it doesn't solve that problem, but it's still a number, but it just checks against those two things. Let's do another challenge. All right, here's a problem that we are going to, here's a problem. So, we're not doing Windows form, so we're going to create a CLI application. Okay, this is a credit card masker, right? A command line application that masks all but the last 4 digits of a credit card number. with an X. So obviously the user, they type in a credit card number and it's going to mask it, replace that number with an X. Except for the last 4 digits. You're going to leave the last 4 digits as it is. Now sometimes users, they type credit card numbers with spaces. So you're going to leave the spaces alone. You're not going to touch the spaces. You're going to keep the spaces. You are going to replace the numbers with an X. Okay. You might want to research or look into the static method char_is_digit or char.is_letter. You can have the program, it doesn't really make sense. Credit card numbers are very specific length, but I would solve it first. If you solve it, like the next thing that you could do, the next iteration after you solve it is you could say, hey, what if they type in a different length credit card number? You could solve the problem for fake credit card numbers, if you will. So this is kind of like P2. Okay, I would call this part 1. I'll call that P2. And I'm going to put this into part 1. The program must support credit card numbers that have spaces, dashes, or no separator. So you maintain spaces, you maintain dashes, right? Or if they don't include a separator, that should also solve. So part 1, part 2, and again, if you're watching this in the future, you can pause it now and try to solve this problem. All right, just like the last one, there's many ways you could do this. This is how I have solved it in the past, and let's take a look. So first step, get the user input. So very similar to what we've done already, just getting a credit card number. One thing worth noting here, a little bit of a discussion around variable scope. Notice how I declare the variable on line 15 so that I can use it in the loop, as well as notice this block, this do, ends on line 20. So if I declared ccnum on line 19 inside of the loop, that variable will not be accessible outside of the do loop. Okay, so you have to declare the variable outside of the loop, outside of that block of code, so that it's available inside the loop and outside the loop. Okay, so that's a little bit on variable scope. Okay, now I'm going to create a new variable called masked_num. Okay, I'm going to start it to an empty string. Okay, then I'm going to loop over the unmasked credit card number and build the masked number. Okay, so I'm going to loop over it and one character at a time build the masked number. So what does that loop look like? Okay, it's a for loop. So to kind of start here on line 25, we're starting off at position 0. We're looping while the index is less than the length of the credit card number, and we're increasing by 1. That's a very standard loop. Okay, on line 27, you're going to see if the credit card number sub-0 is a char, that is a dash, or it's a white space, or the index is greater than or equal to the length minus 4. Okay, so we're in these conditions, we take the masked num and we append the number. We append that. Okay, so basically these are the situations where we do not mask. Okay, if it's a hyphen, if it's a space, or if it's basically the last 4, right? That's what this last condition is. If it's equal to or greater than the length minus 4, it's basically the last 4 positions. So these 3 situations are the situations we do not mask. The last 4, the hyphen, or the space. Otherwise, we append we append an X. Okay, so we're looping over the unmasked. There's 3 situations we don't mask. Here, we append that to the mask num, otherwise we mask it. Okay, so we get the input, we create the mask, and then we output the mask number. Okay, so taking a look at this, kind of do the spaces. We could do dashes or not, and we maintain the dashes, we maintain the spaces. We do not mask the last 4. If we do not include spaces, it does include that, and even if we do shorter numbers, it works as well. Sir? Yeah, so the question was around, what if you only type 4 numbers? It does not mask the 4 numbers.
Why do you use angle brackets for the if and else statements?
The if statements, in this case, are checking for exact matches. So the angle brackets is like less than or greater than. It's like a range, whereas the double equals, or these are exact scenarios that we're checking for. Very good. Let us move on to talk about arrays. Let's right click, add new project, console app, arrays, proj 6, I believe. All right. Syntax for creating an array is, of course, with the angle brackets on the data type. And what this allows us to do is store many variables in a single identifier. So in this case now we have 10 integers, 10 whole numbers. What's beautiful about arrays is that they all store the same data type. So I cannot store a decimal in here because they only allow a single data type. And so in JavaScript, that's not the case. You can have an array, and in that array, you could hold a string and a number and a Boolean and what have you. And so again, just going back to the typed nature that is C#, when you look at a variable, you know what's in it based on its data type. And so you can have any data type, you can have an array. You can have an array of string. Okay, now these are dimensioned, okay, which means you specify the number of elements in them. Okay, arrays and loops work like best friends, BFFs, because you loop over arrays. You can also do, there's that syntax, but if you know the values, you can do the shorthand like such. Okay, so if you know the values when you're dimensioning your array, you could just put those in there, and it does show my code. Control dot is a fun hotkey, so if I kind of control dot this, it wants brackets instead of curlies. I think I was thinking JavaScript there of objects. Okay, but this 1.2, 1.3, and 1.5, and then of course 4. Let's just do a for loop and loop over my doubles dot length. Okay, so the length of my doubles is 3 because I've got 3 numbers in there, and console.writeLine, and then you say my doubles sub I is how you pronounce that. Okay, so arrays are pretty simple in the sense of like you put data into them and then they're referenced by their subscript, or you might call that their index. Okay, and again, that's why the convention for for loops is the I. It's because very often I is used as the index inside of an array to do to have a good identifier. So let's start up 6. And put data into an array and spit data out of an array. We could have an array of type string, and put in some names. Loop over that. Now, kind of going back to the for each loop, for each string name, I just want to also highlight for each loops are for reading. You typically don't use for each loops to put data into a string, so for each loops are more of a read operation. Reading data out of an array. Like we're not using a for each loop to put data into that array. Because again, here what you get is each name out. So console.writeLine name. Okay, and read the data out of the array. So for each loops are read operations. They're not typically for write operations or insert operations, as you might consider that. But if you want to do something else in here, you could do something like, a typical example is say, hey, console.writeLine, who are you looking for? And if name dot equals name dot, let's lowercase, to lower, if name dot to lower dot equals name dot to lower, console.writeLine name was found, and let me get my okay, so what do we have here? Now that we have an array, let's kind of back up. Arrays, anytime you have a lot of data, whether it's names or ages or records of any sort, users inside of a database, products inside of a database, orders inside of a database. When you start working with collections of data, there's normal operations. You're going to start talking about, what are the normal operations? You might want to sort the data in some sort of way, alphanumerically, reverse alphanumerically. You might want to search through the data, search for a particular value. And so sorting and searching, there are sorting algorithms, searching algorithms. There are different ways that you can sort data, and just computer science, majors, they, you know, very often they learn 4 or 5 sorting algorithms, and you know, different scenarios work differently depending on the data for what is the most efficient way to sort your data, right? You want your application to run fast, and if you're choosing between sorting algorithms, you know, you want to choose the right way of sorting the data so that your program runs fast, okay? But the point is, you know, as you start working with collections of data, you got to be familiar with, you know, writing your own sorting algorithms, or writing your own search algorithm, if you will. This is kind of a searching algorithm. And what you could do, you know, bool found is false, and set found to true. And at the end of this for each, you could say if it's not found, then console write line name was not found. User not found. Okay, so point that I want to make here, when you start talking about arrays and collections of data, there's normal operations that different languages have different ways about it. What's unique about the, you know, bubble sort is that it's kind of agnostic of your language. You can write that algorithm in whatever language you're in. And so, you know, you learn these things along the way. And I need to actually do something like, who are you large? I didn't finish this correctly. So string user search, I didn't write this right. ARCH equals console.readLine. Okay, so now we're looping through if user search. If what the user is searching for, to lower, equals name to lower. And then put a semicolon there so that works. And it may be null here, so I can continue to loop over that. I'd put that in a loop so that doesn't happen. Now that should work. So if I'm searching for Evan, I can type in lowercase Evan. It says Evan was found. Bob, again, it's not sensitive to case, but if I'm looking for Scott, user not found. Okay, so arrays and loops are best friends. Conditional statements inside of there to write a simple search algorithm in searching through the data. What else do we want to talk about? We're going to get to that. Yep, we're going to get to lists. There is a built-in method in C# to sort, right? And so if I just for each over my strings and write that item out, now you'll see, even though I put the data in, that sort's a real easy way of sorting data in arrays. We learned how to reverse a string. You think you could reverse an array? I think you could. So let's just do a standard for loop. Let's start as Tim demonstrated. We're going to say myStrings.length -1. So we're going to start off at 2 in this case, while I is greater than or equal to 0. Let's print that out. So again, we're starting our iterator at 2. We're looping until it's equal to 0. So 2, 1, 0. and print out the string. So it's going to be, this is reverse. Ooh, I didn't write my loop correctly. So why? So we're starting off at 2. What did I do wrong? Hold on. Forgot to decrement instead of increment. You did see it printed out Jane, and then it broke. I forgot to change my increment to a decrement. Right, so we know how to sort with array.sort. You could write your own sorting algorithm, of course. There is something built in. The efficiency of the built-in, I will say this sorting algorithm historically was not considered the most efficient sorting algorithm. If you wrote your own manual sort, a very simple sorting algorithm that is custom built can sometimes perform better than the built-in array.sort. Now, I will preface that with saying that that's how it used to be in C#. This sorting algorithm I considered it slow, but it is built in, and maybe it's improved. If you want to, there is a clear method. Clears the contents of an array. And so you would use it just as obviously that doesn't really have any context here, but if you wanted to do that. What else? Now, if I wanted to add, JavaScript is really friendly. So we've got 3, and if I wanted to add a 4th, that would be my string sub 3. Okay, so different languages handle this differently, right? So how is this handled in C#? Let's say we dimension an array and then we make it bigger. Okay, does this work in C#? So if I notice that causes a problem, if I take that line out, everything's working. Okay, so what we've done here, okay, is shown that redimensioning array, making it bigger after you set its size, causes an exception. Okay, it crashes the program. So in JavaScript, you can very simply redimension an array, make it bigger anytime. Okay, that is not the case in C#. Okay, once you set the size of the array, you can't do that. Now, that's where lists come into play. One of the big benefits of an array, of a C# list, is that a list, you can dimension the size of a list, and you can make it bigger, you can make it smaller. Lists are dynamic in their size. Okay, arrays are not dynamic in their size. And so we are going to start talking about lists, but I did want to show that. And then there's one more method worth talking about before we move on to lists. And maybe one more exercise. Maybe. One more method is the index of. So you can see here, array.indexOf is a static method, and it returns an int data type, so it's going to return a number, and it searches for the object and returns the index of its first occurrence. getting this syntax. It says, okay, so here we have to pass in the array. So there's actually, if you look at the signature of this method, I ignored it and I used a different. It accepts what array are we looking through, and then what are we looking for. So these are the overloads. There's actually a bunch of different ways that you could make this method call, but the first one's probably the simplest. We got to say, what are we searching through? We're searching through my strings, comma, and then what are we searching for? We're going to look for Bob. Okay, and then console.writeLine, we would say Bob was found at position plus position. Okay, so we just do a little string concatenation here. And so this is a way of searching through an array for a particular value versus what I did was wrote my own search algorithm. This is searching, and what this returns is an integer position, which can be very useful if I write it correctly. Now, let's see. Oh, that's still crashing that right there. I need to get rid of that. Okay. And close but no cigar. Let's see what I did wrong. Yeah, it is. Thank you. Good catch. I sorted my array. Therefore, Bob is position 1. Thank you. Thank you. Let's. This Evan should be index 1, correct? Evan is index 1. So now I just got to update my literal value to say Evan was found at position 1. Good catch, because I sorted it so it changes my position. Okay. Okay, here's the challenge. I'm going to make it up on the fly a little bit. Okay, now again, this is a challenge number what? We're on challenge 6. Integer array. Woo. Had more to delete. Okay, so I'm going to give you an array. Called test scores. Okay. So these are your test scores, and you're going to have 100, a 90. You were sick one day and got a 30, and then you got some randomness in there. I want you guys all to random numbers. Okay, so these are your test scores. And I want you to write the C# to determine the best score, the worst score, the average score, the sum, okay, not terribly hard, but you're just calculating some basic statistics, and you can use my manual scores or you can make it dynamic. You can ask the user for how many scores do you want to enter, or you could just hard code the input. But you're just going to work with that array, and you're going to search for and spit out. You're going to return to output the best score, the worst score, the average score, and the sum. That's your next challenge. Let's go through it. Jason's going to help me here.
I'll post it.
Ah. We're taking it to the chat. Okay, so we're going to start the best off at 0, the worst off at 100. Why is that?
Well, because it can only go lower than that. That's like the highest it could possibly be.
Yeah. Yeah, so you're assuming that most likely the worst is either 100 or lower.
Yes.
And you're assuming the best is either 0 or higher.
Yeah.
Yeah. And the sum is 0 because that's where the sum starts.
Yep.
Yep. So let's take a look. We're going to for each over our test scores using the index I for the iterator.
Well, it's not really an index here, so I guess
It is an iterator, yeah.
Yeah.
Yeah, whatever you want to call it, but so okay, line 11, best is assigned equal to int dot max either 0 or I.
Yep.
Right? So int dot max is a method built into, it's a static method, and it says it compares two values to compute which one is greater. Int dot min compares two values, which one is lesser, and then sum. So, and then we got a little string interpolation where we're spitting out the best worst. Okay. Anyone else want to offer a separate type of solution? You could throw it in chat. Yep.
You want me to?
Yeah, throw it in chat. No problem.
Mine's like super simple.
The assignment's not going to be due till Sunday, so.
Yeah, so this assignment isn't even due until next Sunday.
For this, like,
This assignment, which is Chapter 1 Lab, right? Chapter 1 Lab. Woo. Okay. This is Project 6. Is not due this Sunday. It's due next Sunday. We're going to come back Monday, and we're going to continue on Monday. So this is max, min, average, and sum. All right, so we had another solution that looks as such. Okay, so we got our test scores. We spit them out, kind of what they are, and then we use these built-in. Now these are built-in methods that are accessible to an integer array. Okay, more specifically to the. Did anyone write their own logic as opposed to using built-in methods? Because these two solutions use built-in methods. Did anyone write their own if statements?
I did.
For loops? Who said that? Can you spit out your code? Let's look at a third solution.
My code is on there. Is Kieran?
Kieran, okay. All right, so here's a third one, and let me find Kieran's. Okay. Again, kind of like Jason, kind of starting the best off at 0, the worst off at 100, and the sum here. And again, in doing the average, doing your own calculation. Based on what I understand about those built-in methods, again, I'm always a little hesitant for performance. They're not the most performant. So, again, is it negligible? Does it really matter? Computers are so fast nowadays. You know, probably not. Probably you guys are fine using these built-in methods, but anytime you can do something a little bit more, write your own algorithm. My understanding is, and you know, I've seen this happen before in the past, I will at least say, unless it's been updated, something like this is going to be more performant than using the built-in methods. Again, that's the way it's been in the past. So, you know, I'll let you guys, whatever solution you want to implement, these are all fine by me. And so we'll kind of hold this here, and then we're going to go on and talk about some other collections besides arrays. Next up, and I'm going to close this, I'm going to open up my next project, and we're going to talk about lists and dictionaries. What am I on, 7? I literally just was there. Was it 7 or 8? It is 7. I already highlighted the shortfall of arrays. The shortfall of arrays is the strength of lists. The strength of lists is that they are dynamic in nature. And the syntax for creating a list is such, and you can access them through their subscripts, and you can make them grow in size, you can make them shrink in size, right? The benefit, now, okay, before lists existed, if you wanted to increase the size of your array, you could loop over the array, you can make a new array, you could copy the elements out of the old array into the new array, and then you can add more elements to the new array, right? So you'd have to create a separate array that was bigger to make it bigger, or a separate array that was smaller and make it smaller, and then do a copy operation out of one into the other. Okay, so that's like in other languages before they had lists. You know, you could work with arrays, you can make them bigger or smaller, but it was more manual. Okay, lists, I want to show you this. If I hold down Control, okay, and you hover the data type, notice it becomes a clickable thing. So if I click on list, you can actually see the class, you can see the code that generates a list. This is called a generic. It can take in many types. A list, these angle brackets, take in a type of whatever. You could have a list of doubles or a list of ints. Okay, so C# has generics. A type of T is what that's called, that allows your flexibility in your list. But I want to show you this. Everyone take a look. Underneath the list, you have an array. So underneath the hood of a list, you actually are just storing your data in an array. Okay? So, yeah.
So if that's the case, then why don't you just use a list all the time instead of an array?
Why don't you just use a list all the time instead of an array? Arrays are more performant. Arrays, you'll actually get better performance because they're stored in contiguous memory location, like one after the other. Arrays are faster. So if you know the size of something and it's not going to change, you might want to use an array. But because it's actually more performant. But a list, you get some benefits, dynamic sizing, but it is not quite as fast. Okay? And so, underscore items, right? We're ultimately we're putting our items in an array. So lists are great. They're dynamic in size. They're not as fast as arrays, but does it matter in 2025? In most cases, probably not. A lot of students in my class, they just put everything in a list and it's fine. So let's look at, some of the... Now you got the length. You got the length in an array. And you got the capacity. The capacity gets the total number of elements. So if I were to console write line my ints dot count, there we go, my ints dot count, of course, that should spit out if I run the write project. What am I doing? Incorrect here. So, I have to my int sub 0. Okay, silly me. You can read out of a list using the array syntax, but to put it in, it's been a while, but it's simple enough. To put it in, you're using a method, right? So my ints.add 1, add 2, add 3. Even though we dimensioned it to 4, we can add 4, right? So there, you can see that the count returns 4. Okay, so even though we use a method, the add method, to put it in, and then you can use the array syntax to read it out. So my int sub 0 should return the value of 1. Okay? Apologies for the simple mistake, but I forgot that little nuance there. You use the add method to put it in. You can use the array subscript to read it out. But what else can we do? Like I already demonstrated, we can get the dot count, which should be 4. Now there's a capacity. Check this out. So my ints dot capacity, we don't need to convert it to an array. So this is an interesting property of the list. The capacity is how many elements it can store. So what happened is we started it off at 3. When we added a 4th one, it doubled the capacity to 6. So there's a couple of unused spaces there. If I add a 5 and I add a 6, notice the capacity should still be 6. But if I add a 7, you could probably guess it's going to double to 12, right? So this is the how many elements it can store. This is the number of storage units. Okay, but you're just seeing that the count is the number of elements in the list. The capacity is how many elements it can store before it redimensions itself. Of course, there's a clear, which you can assume what that does correctly. It should remove everything. There's also, I forget what the trim is. Trim excess. So even though we've got okay, so if I don't trim the excess, I essentially have wasted memory space. I'm storing 7 elements, but I can store 12. I've wasted 5 spaces of memory, right? So I've got wasted space. And trim excess gets rid of that wasted space. It changes my capacity to be the count. Which is, if you're really gung-ho, saving memory, every ounce counts, you might consider doing that. Let's go back to the documentation. You could add a single value. You could add a range of values. It has a built-in binary search. It has a searching algorithm built in. So let's check that out. My ints dot binary search. Okay, so we've got overloaded methods here. So the first one takes in a value and returns an int. So it searches the list for an element, and it will return an int. So like, let's say I'm looking for the number 5. Okay, and you saw there that the binary search returns an int. Int position equals. So I would say something like the number 5 was stored in index position. Okay, so this is going to return the index value where 5 is, which should be what, index 4, I believe is the output. So the number 5 was stored at index 4. Okay, so that's the binary search. Back to the docs. There's a find method. searches for an element that matches the conditions defined. Yeah.
We're searching out for, you're looking at NET 9.0 stuff. We're using, just in case you didn't know.
Thank you. Searches for an element that matches the conditions. And so you have to pass it, in this case, a predicate, which we got to dive into those. I think this is where you could send like a link query kind of thing, based on let's see, examples. Okay, so here we've got a class, and we're going to get into classes here shortly. So I have a list of parts, and we're adding some parts. And here, exactly, a link query. See this? Parts.find, a part where the part name contains a seat. So this find is going to work with a link query such as this. Okay. Now, obviously, our example isn't quite that advanced, but I just wanted to show. And you guys have written this kind of syntax before in the JavaScript class. So I believe a lot of these methods, like the exist method, will work the same way. All right, you can sort. There's a built-in sorting out method for lists, and that, you know, in a nutshell, crash course, that covers the list. Then there's also a dictionary. Okay, a dictionary of integer key and string names called students equals new dictionary of int string. Okay, when do you use dictionaries versus lists? Well, if very commonly you're referring to your students by your student ID. Okay, in other words, you've got two parts to a dictionary. You've got a key and you've got a value. So this integer references the key. The key for students are going to be your students' IDs. Okay, so dictionaries really excel when you're doing a lookup by a key. Okay, so dictionaries excel over lists when you're trying to find something fast by a key value. And so that's the strength of a dictionary, is data retrieval when you're doing searches by key values, and you want those searches to be really fast. You might want to store your data in a dictionary. So students.add 22698, that's the student ID, and this is Bob, and that's how we put data into our dictionary. And so you can kind of add some students here, and and council. Now there is a for each loop. Let's see the syntax for this. I might yeah, let's see. All right, and so let's go to the methods of the dictionary. We've seen how to add. We can look for contains value. It's going to return true or false. So that's pretty simple. If students dot contains value Bob, Bob is in the students list. Okay, so that's one method. But let me show, like if say console.writeLine students sub 1, 2, 3, 4, 5. Okay, that should print out Janice, right? So how do you read data out? Obviously, this is adding data into a dictionary. And this is reading data out of a dictionary. Okay, so when it comes to our data structures, you know, what are the different ways that we can put data into? We got arrays, we've got lists, and we've got dictionaries. There are others. These are the most commonly used data structures. Let's do a programming challenge. Okay, here is your programming challenge around using a dictionary. Okay, this is something you guys have done for me many times, and that's just CRUD applications. Okay, we're going to work with CRUD application of a dictionary to work with users to add, retrieve, update, and delete contacts, where the user's key is the contact name and the value is their phone number. So we got a dictionary of string. Again, the key is their name and the value is their phone number. Now you present the user, maybe you do this inside of a loop. Okay, so present the menu in some sort of loop to what do you want to do? Do you want to add a contact, view a contact, update a contact, delete a contact, or list all contacts, or end the loop? Okay, so there is your next programming challenge. This one will take a little bit more time. All right, let's take a look at one student solution. And so to kind of start, we're going to define a dictionary of type string. We're adding in Evan, John, and Jane. Okay, so these are the keys and these are the values. You can look users up by their name and return their values. Big old loop, a big old do while. So this is all in a do. While. And at the end, while exit is still false. Okay, so we know we want to continually prompt the user for these operations, so we're going to put this in a big do while. And so now we ask the user to put in a number value, and you know the menu you can kind of see here with new lines: add a contact, view a contact, update, delete, list, and 6 for exit. Ask the user to enter their choice. Nullable string choice shouldn't really make a difference, but notice in this case it's basically could wind up putting a null value in potentially. So to make the compiler happy, you mark it with a nullable string, and that makes the green squiggly go away. So you see that a fair amount. And kind of, you could go with a switch here. Kyle went with if statements. If the choice equals 6, we set the exit to true. Else if the choice is 1, we prompt the user to enter a name, store that in a variable, enter a number, and add a new contact if it's 1. Else if it's 2, let's enter a name, determine if it contains the name. If it does contain the name, print out the name and the number. The number is accessible through the phone book sub. You put the key in the brackets. Of course, the key in this case is the name. So that works well. Otherwise, you say user not found, contact not found. So that's the option for 2. The option for 3. Again, prompting for a name. So this is an update, right? An update, we ask the user for a name. If that name exists, we enter a new number and set the new number, the new phone number for the user. Again, using this syntax. So this is an update operation. Otherwise, we say contact not found. Option 4. Similar in difficulty. Whoops. Let me Control Z that. Yeah. Else if. Option 4, which was what? What was 4? Delete. Ask for a name, and then remove them by their name. So that's your delete operation. And last but not least, and I'm glad we're showing this. A for each loop that iterates over a key value pair of type string. So this is listing all of the contacts. And what's nice about this is this is one way to iterate over a dictionary. So we're iterating over a dictionary using a for each loop. And then each contact, you can use the contact.key and the contact.value. So this is something I did not show, using the key property and the value property inside of a loop. Yeah. Okay. Yeah. Thank you. Voila. Run that. All right. Start by listing the contacts. Adding a contact, viewing a contact. So there's the view, there's update. Let's update Billy to a new number. Let's go back to viewing Billy. All good. Let's delete Billy. And then list all contacts again. Billy's not in there. 6 is exit. Job well done. This code does not have to be exactly like yours. You can code how you wish. Glad we showed off the key value pair iterating over a dictionary. That's good stuff. Yes, we are going to move on to talk about functions or methods. A lot of time the two are used interchangeably. So I might call them functions, I might call them methods, but let's start with another project, and so we could begin that conversation.
For some reason I like to call them
So the project name, 8, and start with the theory as we do on methods. And this is starting from the ground floor, access modifier. So typically methods start with an access modifier. Now, okay, so where do we start? A method starts with an optional, you could leave this off, okay, access modifier. Okay, if you leave it off, there's a default, which we need to get into, scope. We haven't had that discussion yet. So the access modifier modifies scope. In other words, what parts of the program can access this method. Okay, so this access modifier modifies scope, where you can use this method or where not. Then methods are also either optionally marked as static or non-static, right? So you could just have a method optional. It's either static or non. And when you mark a method as static, it does a couple of things, but the main thing there is that the main thing when you mark a method as static is you saw that static methods were called differently. Static methods were called by their class name, method name, and if it's a non-static method, it's called by the instance field method name. So this keyword here changes how this method can be called, and that's in short. Then, so we have access modifier, then we have static. So our access modifier is public, protected, there's one called internal, and there's private. So these are the different access modifiers. Then you either say static, keyword, or nothing. I mean, it's either static or not static. So you could leave the static off. What comes next is the return data type. Okay, so this can be a data type like an int. It can be an object like a student, if you were to create a student object, or a string, of course, is a reference data type. It could be a double. If your method doesn't return any data to a calling to another method, of course, that's when you do void. Okay, so that's that. Then you have the identifier. Okay, my identifier in this case is do something. And so this is just the method name. And of course, the programmer gets to define the method name. I called mine do something when, a lot of times when you have silly methods, you use conventions like foo and bar and things of that nature. But this is the identifier. And then you have the parameter list inside the parentheses. Spell that right, parens. Okay, and so this methods don't have to have parameters. You could have no, these are optional, right? So they could have none, they could have one, they could have many.
Are you allowed to have public and static at the same time?
Yes, yeah.
For me, it's saying here, public is not valid for the site.
Yeah, so is anyone else, as you're typing this, getting that error?
Public does not work at all.
It doesn't work, yeah. So if you leave public off, the word static does. Yeah, and I've seen that before. And so the reason for that is because we're inside of the main method, and that's being abstracted. You can't see that we're inside of main. So you can't declare another method like that as public inside of main. So you leave that public off. Now, I just wanted to show that because now if you do static void, does this work for you guys?
Yeah.
Okay. And okay, so let's just do this. And so if I just kind of just in the most simple like this, and then we do that. Just to make sure that I'm up and running. Now maybe it's because I'm not running project 8. Okay, so that's, it's most simple. And if you were getting the access modifier barking at you, we will use methods with access modifiers when we start getting into classes. For right now, we don't have multiple files. It's all in one file. So we don't really need to worry about sharing this method with other files or marking them as private or anything like that. Okay, now if I add a parameter here, you can see that's going to error out. This is not an optional parameter. If this is now a required parameter. So foo is expecting a number, and therefore, in order to get that to work, we need to provide that input, and then the method can use that input. Okay, right off the bat, there are these defaults. And so if I call it like this, it will overwrite the default value. But if I leave that off, now there is a default value there that will be assumed. And so this, the way this is, it provides a default value and it becomes an optional parameter. Instead of a required parameter, it becomes an optional thing. Because if you leave it off, it assumes a value. Okay, and of course data types have to match. If I were to say like this, well, data types don't match. You cannot pass a string into an int, obviously. Okay, so when it comes to methods, we have access modifiers, we have static or non-static, we have return data types, we have the method names, and we have the parameters, which are, if you put them in there, they could be mandatory parameters, they could be optional parameters. And that is a quick overview of some of the methods. Let's see. So that's optional. There's also named parameters, and I tell you, I don't love named parameters, but let's do int bar, int bar with 2 R's. And so this foo is expecting 2 ints. Okay, so number 1, and you can see that as I begin to type foo, you see by the way, all this together, this is all together called the method signature, which the method signature is actually it's not all, I believe the signature is just the name and parameter list. So you might hear the term called method, if you hear the method signature, the method signature does not include the return data type, the access modifier. No, one second, I gotta double check myself. Okay, yeah, I was right. The method signature is what uniquely makes the method. So what uniquely makes this method is the identifier and the parameter list. What is not part of the method signature is the return data type, the static or non-static, known as a modifier, or the return data type, or the access modifier. Okay. Why do I say that? Very commonly, you can overload methods. An overloaded method have the same method name, but a different parameter list. So you guys for sure should be familiar with overloaded methods. Okay? How are these useful? Well, an easy example would be, let me return an int. Like if we're writing a method called add, this method signature takes in 2 inputs and has 1 output. That output is returning num1 plus num2. Well, very simply, we could overload the add method, and now it can add 3 numbers. Okay, so this now it is barking at me because I do have, it's not letting me overload my method here, and it might be because this needs to be on a class. Let me just try something here real quick. You do not have to follow along. My gut tells me if I add a class called whatever, it doesn't really matter what my class is called. I'm going to mark this as public. I'm just going to take these 2 add methods into here. Now I can mark them as static so they're not. Okay. So as we begin into writing classes is when we can actually overload our methods. This is barking at me because, again, we're kind of working inside of the main method. But nonetheless, now this add method is overloaded. And so there's a few ways to overload methods. One is by the number of parameters. Notice 2 parameters versus 3. And another way to overload a method is by its data type. So if I say public static, now again, it doesn't matter. The signature has to be different. So the return data type is not part of the signature. But now notice if I say double num1, double num2, okay, and return, notice our data types in the parameters are different. So now we have 3 overloads. We have 3 overloads that are available to us. So now we can add ints and we can add doubles. And so you see overloaded methods all over the place. In fact, we've already called overloaded methods. We've already called overloaded methods, you know, in our different demonstrations of code chunks. Let's see what other method concepts. Oh, I left off on named parameters. I didn't talk about named parameters. I don't know how I got off on overloaded methods, but I did. Let me back up and make a static int foo. Okay. The convention is you pass the order. If you pass it by the correct order, you can do this. If you are writing foo, please take a look. you can see the parameter name when you're calling the method. You can see that there's a variable in there called bar with one R, and you can see another variable called bar with two R's. And so there's a way to pass into the bar first. You could say, if I want to pass 6 into that one, and I want to pass 10 into that one. So you can pass by name in the method call. Okay, so that is, these are referred to as, named parameters. The reason I don't love it is you're exposing a little bit about your method in the method call. You're exposing the name of your identifiers. And a lot of times you have this concept of encapsulation and kind of hiding your data from other parts of the program. And so I don't know. I don't love needing to know the identifier names in order to call the method. So it's not something I particularly use a lot, but it does exist where you could pass in a different order. And why? Well, maybe that prevents some overloading. Maybe you can prevent some overloading by passing your data differently, so you don't have to write 50 overloaded methods. Maybe. But that is named parameters.
I'm noticing it also lets you type them out of order.
It does. Yeah, let's just type them out of order. Order doesn't matter as much. There's also an out parameter. Now this is going to change. So this is the last thing here. It's been a long lecture today. For following along, there's some keywords that you can put in your parameters, like out and ref. And let me not pass by name anymore. There's some rules around this, which is not, it says use of unassigned out parameter bar. And so we need to out the call here and out the call there. Oh, it needs to be an assignable. Okay. Int num 2. So we say out num 2. I know this is not making sense right now, but I'm getting there. This all has to do with how data is passed. And so our variables, our integers, are passed by value. They're called, the value data types versus the reference data types. And so when you pass by value, that is to say that the outer variable does not get changed. But you can change that. You can pass variables, instead of passing them by value, you can pass variables by reference. And out is one way to do that. And so regardless of what this function does, by passing these integers by using this keyword of out, this function can now change num and num2. This function used to not be able to change these variables that were outside of its scope. But if I console.writeLine, regardless of what that function does, num, let's just say up here num is 1. Okay, num gets passed into bar gets assigned to 0. Like if you're just looking at this line of code, you might expect num to still be 1. But because we're passing by out, now I expect that to output the value of 0. Okay, so using these keywords, again, this is something in programming that was a super head scratcher for a lot of beginners. Because you have to understand that ints are passed by value, which means that inside of a method, you can change the parameters, but it's not changing the outside variable, the variable outside of the method. Okay, and ref is very similar. Ref is very similar to out, except for there's one little nuance difference between ref and out, and that is that out, you actually don't have to have values. Like notice num2. Num2 does not have a value before you're passing it down. Okay, whereas ref has to have a value like outside before it's passed down to the method. Okay, so there's a ref keyword that works practically identical as out with one little nuance rule difference. Okay, so using ref and passing by out and passing by ref changes that. And again, just going back to what we learned about JavaScript and what was referred to as writing functions that do not interfere with other parts of the code, it's borderline worth saying that in JavaScript this would be considered bad practice to have a function change a variable outside of it. Remember that? So again, that's not always considered the best practice to write a function that can modify variables outside of itself. Okay, so just want to talk a little bit about passing by ref. That was not my best explanation of that, but passing by ref or passing by out keywords.
I got the idea.
Well, thank you for paying attention because it's been a long day. That brings us to the end of class today. We've got one more day of this crash course of C#. We're going to talk a lot about classes and objects. There's exception handling to come and debugging. So a few more concepts on Monday. Have a great rest of your day, guys. All right, we are continuing on. I kind of left off here on what we referred to as Project 8, where we were going over a bunch of theory with methods. And we will use this theory as we move on and we start talking about classes. Because classes basically can be described as having two main members. Classes have data is one member, is one thing that if you think of a class, it has data and it has methods. Okay, so of course methods are a piece of classes, so we're going to use them all when we're talking about classes. Now, I have this student file, this student class, if you will. Not sure if I actually had you code this, so I'm going to just delete whatever chicken scratch I was playing with here. And inside of Project 8, I'm going to start with a little bit of theory, and then we'll get you guys with your hands on the keyboard. If I'm going to talk about classes, how would you define a class? Classes are what?
A blueprint.
Yes, that's the textbook and correct definition. Blueprints for objects. Okay, now we come from JavaScript, and JavaScript, we know that our objects can take any shape. And we know because our objects can have, some of our objects in our JavaScript class, they had properties. Other objects were missing those properties. Sometimes those properties had capital letters. Sometimes they were lowercase letters. Our objects in JavaScript had no predefined shape unless you created a class. There are classes in JavaScript you can use. But by default, you know, our objects in JavaScript have no shape. And that's the beauty of C#. All of our things, all of our things that we create digitally, we take a physical thing, you create a digital representation of that. Okay, so all of our things have a very specific shape. Okay, so you know when you have a class, you know what every object will look like. You know all the properties, you know all the methods. They will all be the same if they're the same class. All of your things will have the same shape. Okay, so very accurately, classes are described as blueprints for objects. You could think of cookie cutters. You stamp 100 cookies from the same cookie cutter. Okay, when you think of a blueprint for a house, you know, I think of the neighborhood I spent growing up. You know, I remember the first time I went in my neighbor's house, and I'm like, wow, your house is a lot like my house. And I didn't understand, probably they used the same floor blueprint. You know, the kitchen was in the same place, the bedrooms were in the same place. A lot of neighborhoods are built on similar blueprints because, why? Because they can stamp out houses really fast. Okay? Now, St. Louis has some really unique neighborhoods where they have no two houses that are alike. Okay? And that's actually a very, you know, that's considered a nice feature of a neighborhood when you get all these houses that aren't shaped the same. Okay? Now, I grew up in a kind of standard, you know, subdivision that's more cookie cutter. It's not as fancy. You know what I mean? But blueprints serve as the shape of our objects, and that's an advantage in a lot of developers' perspective. Okay, so to create a class, what you would do is you'd right-click and add class. So let me find the add, and you can add a new item. But there's a nice little right here. There's a class. And again, I think of a class as, okay, any real world thing. Go back to your English class. Any noun in your English class. Person, place, thing, you know, these are nouns. And so you take a noun in the English language, okay, and you take that noun and you can make a digital representation of that person, place, or thing. Okay, so you know, I look around my desk. I've got, you know, pencils. I've got water containers. I've got microphone. I've got a mouse. I've got a computer. I've got the desk. The desk itself. All of these things could be turned into code by making a blueprint, which is a class. A real standard class. Then, you know, you take a person. Okay, it could be a teacher class, it could be a student class, it could just be a generic person, right? A person class. And then, you know, if you were going to create an inside ranking piece of software, and, you know, you might have a student, child, right? A person defines all of the attributes that are generic, and then you can have inheritance. Maybe we'll do this, where student inherits from person. So we'll go down that path here in a little bit. Now, kind of spinning this up, when I add a class called person, okay, I'm gonna walk you guys through. I'm gonna start off working with classes like this is Java, like back in the day. So there's a little bit of history and evolution of working with classes. But Java was the first object-oriented programming language in the 90s that blew up in popularity, that was object-oriented. And so in Java, and keep in mind, C# kind of got a lot of its features from Java. I'm going to pretend like we're writing a little bit of Java here. I'm not going to use the newer features of C#. Okay, I'm going to just use I'm going to start by just using the old features because you still see some of this in C#. Okay, now I want to point this out, right? So I've got this class called person, and there's a couple things. Number one, notice the namespace. A namespace is like a digital folder, okay? It's like, hey, we're going to organize this file in a digital folder called proj8. And I just want to point out here that program.cs, notice there's no visible namespace here. There are some usings in here, but I'm not using that namespace. Okay, so notice if I change the scope, the access modifier on this class to public class person. It is very conventional to have your classes marked as public. Okay, you want them to be used across multiple files, and so it is a convention to have your classes marked as public. But if I were to come back over here and I start typing person, okay, notice I get the red squiggly. It says, hey, the namespace could not be found. So, maybe a couple ways of solving that. Maybe if I come up here and I say using proj8, there you go. Okay, that way we're at least recognizing the code that's in that folder, that digital namespace that is this person. Okay. So now let's start breaking down what's in a class. Broadly speaking, classes have what are called members. Okay, and members are either referred to as fields, which are our data, and as we know, data is variables, or they are methods. Okay, now later on we'll get into some other members besides fields and method, but if this was Java, this is kind of where you start, right? So what is the data that a person might have? And you're going to say, well, probably a string of name. Okay, so like a person's going to have a first name. Now, notice before today, we did not really work with access modifiers a whole lot. The whole purpose of blueprints, of classes, is for code reuse, right? You're going to reuse this class many times, right? You're going to stamp out a bunch of cookies from your cookie cutter, okay? So we're not just working in one file anymore. Before today, everything was just in one file. That file was inside of the main method, and everything just ran in one file. Now these files got to start working together, multiple files to create the software. So we're going to start dealing with access modifiers: public, private, protected, internal. These are all access modifiers that control what parts of the software have access to the code. Okay, so it is convention to mark your classes as public, and it's convention to mark your instance fields. These are even better yet, instance fields. This is an instance field. It's all about the instance fields. Okay, what do I mean by it's all about the instance fields? I mean, at the end of the day, you're working with data, and the methods just work with the data. Okay, so in my mind, in my mind, it's all about the instance fields. Methods are just there to work with the fields, and you have to understand it's all about the instance fields. Even as we start working with methods, those methods are just working with the fields. Okay, and so what is name? And there's conventions here, right? A lot of times your instance fields are marked with an underscore. So for now, we'll use this convention. And then I'll do like a camel casing, like first name. Okay. why is this called an instance field? Because if I have 100 students, each instance of student will have their own unique first name. Okay, now there might be some duplicate Bobs, there might be many Bobs, but they probably have different last names. Or if they happen to have the same last name, they probably have different middle names. And if they have the same first, middle, and last, then they do have unique student IDs. Okay, but the idea of an instance field is that each instance of this variable can be unique. Doesn't mean it has to be, but most of the time it will be unique. That's why it's an instance field. Okay, the opposite of an instance field is referred to as a static field. Okay, a static field is a shared piece of data, so that all of your classes share a piece of data. Like all of you have the same teacher, right? So why would you store the teacher name 24 times, right, in memory? You wouldn't. You would have a shared piece of data that you might mark it as static, like the teacher name. The teacher name would be marked as Gudmested, one time, one place in memory. Okay, let's make another last name. Okay. Now, once you have instance fields, then you start creating methods to work with those instance fields. Okay, and in object-oriented programming, very commonly, these are called accessor and mutator methods. Okay, accessor does what it sounds like it does. It accesses the data. Mutator does what it sounds like it does. It modifies the data. What data? Well, your fields. So we access the fields and we modify the fields. So let's write a mutator method, right? So let's just do, whatever. We'll do one of the accessor. Okay. Well, look how IntelliSense pretty well picks up on what I want to do. I'm going to create a public method. The return data type is string. We're calling this getFirstName, and it simply returns the first name. Now, Mr. G, couldn't I just mark first name as public, and then I could have direct access to the instance field? Yes, you could. Okay, but that's considered bad practice. What's considered good practice is data hiding. Data hiding means your fields are private and can only be accessed or modified by public methods. Why is that considered a good practice? Because your methods can control what goes into those fields and how data is retrieved out of those fields. If you give another class direct access to the fields, you lose some control. Okay? Now in this case, all we're really doing is we're just returning the data itself. We're not really controlling any access, but you have the flexibility to write C# programming logic in here to control access to the data. Okay? So by using this concept of data hiding, this is OOP 101 stuff. You got to know this stuff, right? You control access to the fields through public methods, and you can control what goes into those fields, and you can control the data and how it comes out of those fields. Okay, so this is how we access it, and let's do a mutator. So the mutator would be a setter. Now there's convention here. Notice the accessor has the convention of get. So this is called a getter. You hear it called a getter or an accessor or accessor. Okay. The convention on a mutator has set. Okay. And the mutator accepts one parameter. And notice it assigns. Notice the mutator assigns the instance fields. Remember, it's all about the instance fields. The accessor retrieves the data. The mutator, line 30, it takes one input and it assigns the instance field equal to that input. Okay, now if you just said fn, just to show you here, you know, they don't have to have the same identifier. Okay, but notice how my parameter first name, well, actually this has underscore first name. So that's why a lot of cases it's good to kind of mark those as an underscore, because you always know the underscore is the instance field. Okay. All right. So how do I? Yeah. What's up, sir?
You was mentioning like data hiding. Was that like the same as encapsulation? Like
Encapsulation is the idea that everything that belongs in a class is encapsulated into the class. It's kind of a weird concept to me, because it's like, well, what else would you do? But here's what it boils down to. Not everyone agrees on where the data should be stored. You know, on a student class, it's pretty simple. But in real world software, you know, do you put this particular piece of information in this place or that place? Not everyone always agrees. So encapsulation is the idea that all the fields and all the methods that belong to a thing are put into that thing. You know, think of a capsule. I mean, think of like a time capsule from the 90s. You know, they bury all the things from the 90s, the jackets and the clothes and the CDs and all that stuff in one capsule, you know, in a time capsule. So data hiding kind of plays into that. You know, you're putting all the data, encapsulating into one thing, but they're similar but different topics. Okay? All right. So now, I mean, at the end of the day, what do? Now we can instantiate a person. We can create an instance of a person, and I'll call my instance first person, or I don't know. That sounds like something more specific. First, yeah, whatever. First person. Okay, my first person is new person. Okay. Now, let me console.readLine. I just want to show first person dot get first name. Okay, notice I'm trying to read something before I write to it. This needs to be a right line. Excuse me. Okay. Wait a minute. Why are you trying to read something before you put into it? If I spin this up, you can kind of see it's an empty string. You don't visually see that in the command prompt. But strings, there actually is a value when you instantiate an object that strings are assigned an empty string value. Okay? The reason I just kind of mentioned this is that all instance fields have default values when instantiated. Okay? When an object is created. Strings, of course, it's either empty string or null. It might be null, and my memory is off on that one. Strings are null, but I want to say empty. Either way, you can see there's no value there. Integers are 0. That is correct. Booleans are false. Floating are 0.0. Okay, and this is actually important as we delve deeper into this, is that you need to understand that all your instance fields do have default values and remain that unless they're changed, which is different, right? If you just declare an int that's not an instance field, and you try and read that value of that integer, that will cause a compiler error. You guys remember that? right? Like if I just over here, if I just say int x, and then I try and counsel right line x, see that? So instance fields do receive default values, whereas this would be more of what's referred to as a local variable. It's local because it's just declared inside of the main method. It's local to the main method. And local variables do not receive default values. Yes, Paul?
So, if you were to declare an instance field as nullable, would it just give the value of null instead of the default value?
No, it'd still take the default value. And that's a great question. Like if I just declare these as nullable, okay, and I come back here and spin this up, it's still gonna, yeah, just give you the, yeah, that's why I think it's an empty string, because I think a null value would literally print the word null. Okay, but obviously our first person wants a first name, and I'm gonna do first person set first name to John. Okay, so now we instantiate an object. That object, that person, has an empty first name and has an empty last name, but we're going to change that. We're actually going to give our person a first name of John, and if we set it up correctly, now it spits back out the person's first name is John. Okay, now I did this for first name just for you guys real quick, and this is not a challenge per se, but go ahead and do the same thing for last name. Go ahead and create an accessor, create a mutator, give the person a last name, and spit out in one write line, say the first name is blah, the last name is blah. Okay, so you know, pretty straightforward. In fact, did you guys IntelliSense like mine? If I public string get last name, does it almost practically fill it in for you? Yeah, so these are very templated stuff. I mean, accessors and mutators, very like I said, this has been around since Java in the 90s, so it's very common to have I'd call these like the boilerplate accessors and mutators. You know, these are the templated, like very straightforward. So there's that. Now, okay, so let's do first person set name, and then also say.
I actually had to like type mine out myself. Like,
Oh, what is this? 1994?
Right, mine tells me it doesn't work like how yours be working. I have to be like, why mine didn't do that?
Okay. Now these are methods, right? So I do want to point out pretty quickly, so the convention on our methods is that they're capitalized, capital letter, and these are accessors and mutators, so they have gets and sets. But pretty soon we're going to work with something different called properties. Okay, and properties look just like methods, except they don't have parentheses. Okay, so when I'm over here, you know, you got to realize that if it's got the parentheses, you're working with methods. If it doesn't, you're working with what's called a property, which we haven't talked about those yet, because properties didn't exist in 1992. We only had instance fields and methods. Sir?
Why are we instantiating last name on this line? Next up.
Oh, yeah,
It's already instantiated.
there's a dollar sign right before it.
Oh, that's what you're saying. Thank you.
I was kind of confused by that.
Thank you.
I tested it out.
So now we got the name is John Doe. Okay. All right, so you got to understand what fields are. You got to understand methods interact with those fields. And then you come across this idea of a constructor. What is a constructor?
It's a class used for building your object.
Yeah, a constructor is a method. Okay, so let's start with that. It's a method that has the same name as a class. And it has no return data type. Okay, so a constructor has the same name and no data type. And it is used to initialize the object with other than default values. So you guys see right now, when I call this, this is calling what's referred to as the default constructor. It has no arguments, no data inside of these parentheses. Okay, when you use the default constructor, all of the instance fields assume their default values. If you know when you're constructing the object, if you know the values that need to go into the instance fields, you can create a constructor that will effectively replace these mutators. These mutators are putting data into the instance fields. So I think of a constructor as a mutator. It is a method that's going to populate instance fields with data. So a constructor, it looks very something simply like this: public person. Now, instead of this, I'm going to do string first name, string last name, and I'll allow the data to be passed in. Okay, but notice what I'm doing. I'm initializing my fields to have different default values, whatever is passed in. So this is clearly a 2-parameter constructor. Okay, now you're going to hear, sometimes they're called parameters. So when you're defining the method, the data is called parameters. When you're passing it into the method, a little nuance there is that many times they're called arguments. When the data is being sent in, that's called an argument. When you're receiving the data, it's called a parameter. Jamisha, you had a question? Or do you?
Is this not the same thing that we do on below?
It is. It allows flexibility.
So it's like a shorthand?
This is a shorthand. You can think of it as a shorthand. It does both.
I was thinking about doing it, but I didn't know.
Yeah. It's effectively doing the same thing that we're doing below in one method instead of 2 methods. So now, okay, check this out. So I'm going to go over here and I'm going to use this. Wait a minute. What happened here? When you create your own constructor, you no longer get the default constructor for free.
You have to build it.
You have to write it, right? So you guys might remember that. This is what's referred to as a parameterized constructor. If you write your own constructor, you no longer get this for free. Okay, actually you don't even need that. Okay, this is the default constructor that you get for free. You don't have to code it unless you code this, and then you no longer get this for free. Okay, so this is my first person object. Now I'm going to say person second person equals new person. And now notice I've got an overload. My constructor is overloaded, and I can write my constructor in one of 2 ways. I can use the default, or I could pass it 2 strings. So I'm going to say Jane Smith. And then I'm going to copy and paste this right line. And this is going to be second person first name, second person last name. And if I should be able to break this. Notice how I'm concatenating with this plus symbol right here to break that up into 2 lines, just so you guys can see it. So it's kind of, that constructor offers flexibility. It also allows me, well, what if Jane Smith got married and later on in the execution of the code you want to change second person's last name? Well, I can go right in here and I could say second person dot set last name. Maybe she married John, right? So you set the last name to Smith, but then you're modifying it to Doe later on. You can use both. You can use one, you could use the other, you could use both. Okay? So I think of a constructor as a mutator method for multiple instance fields, which is nice. I'm going to say that again. A constructor is a mutator method for multiple instance fields. Might there be an accessor method for accessing multiple instance fields? And the answer is yes. The convention, check this out. So, a little bit of theory here. Person has an implicit or automatic inherit from object. Person is a subclass of object. Why is that important? Well, object has some methods that you inherit. I didn't have to write this method, but we get it for free. If I come into here and I say something like first person dot, notice I got a get type, I got a toString, I got an equals. These are all methods. Where do these methods come from? Well, they came from the object class. These are inherited automatically from the object class. So this toString method is really interesting. If I do a console.writeLine, I'm going to write line first person dot toString. I'm going to show you what that looks like. Not really useful. A toString, it just tells you the data type. It's a person data type, and that person data type exists inside of a namespace called project. So this toString method, out of the box, what you inherit for free, is not very useful. Okay, but the convention is to overwrite that toString method and make it useful. Okay, so it is very common in object-oriented programming to override, if you will, the toString method. Now check this out. I'm using a keyword override because that method already exists. And I want to override its functionality. I want a new functionality for toString. This time it's going to return a string, a public access modifier, and it's just going to return the person's name, his first name, last name. This toString method is an accessor for multiple fields. Does it have to be all the fields? No, it can be whatever fields you want. But you can access the data from multiple fields using the toString. Okay? Just like you can modify multiple fields using the constructor. So what does this allow me to do? This allows me to over here, notice all this? I could just replace this with second person, toString. Right? So we're accessing one piece of data at a time, or we're just going to spit out the person's name is first name underscore last name. And you'll see here there's actually a shorthand notation. I'll show this off here in just a second, but let me run it. Now it doesn't, you kind of get, it's now it just says the person's name is Jane Doe, right? We lose a little bit of recognizing what person it is, but nonetheless, that's how you work with toString. Okay, and I believe what this is trying to tell me is that if you just do this, just put the identifier for the object itself, that automatically calls toString. So this is like object-oriented programming in the 90s. And what I would do next, okay, Real quickly, just for you guys, make an age instance field. Okay, make an age instance field, and write a mutator and an accessor for age, and include it in your constructor, and include age in your toString. So here's the exercise. Okay, I'm going to write this down. Okay, create an age instance field with accessor and mutator methods. Add age to the constructor and the toString methods. And then I could do something with a number like an age here after you guys do that real quick. Okay, so we're going to continue marking our fields as private. We're going to add the age field here and initialize it here, and is this many years old? Bless you. Okay. Okay. So now we lose this constructor here that just had two strings. We now have to pass the third argument, which is the age. Okay, and when we spit out the second person, it should spit out their age. Okay, $40. I keep doing that. This is the JavaScript syntax that I need to forget we're not using anymore. Okay. Quick point, and then we'll move on a little bit. The point that I want to make is that when you start having numbers, the next thing to do is like, well, now we need to start talking about calculations. Okay, and maybe if you have an age in years, maybe you might want to figure out, well, how many days old? A simple calculation would be, how many days old is this person? So you might think to store something like this in days old. But when you have a variable, and this is not a huge point that's worth spending a lot of time on, but when you have a variable that's dependent on another, like the calculation of how many days old is directly dependent on age. So you might say days old is dependent on age. Okay? You probably do not want to even create this variable, because what happens? Okay, if you're 1 year old, then your days old is 365, but as soon as that age increments to 2, there's a chance that you don't also increment days old, right? So days old, there's a chance for stale data, okay? This is a possibility where, because this is dependent on this, if you update this and you don't update this, a common problem that happens, it might seem like, well, I would never do that, but it happens a lot. It happens frequently. Okay, so stale data is a common problem. So instead of creating a field that's dependent on another field, you might just write a method that calculates the days old and returns the data. So I'm going to write a public method. It's going to return an int. It's going to be calc days old. And it's going to return the age times 365. That way, when the age updates, then you just call this method, and it would return the current underscore age, the current age times 365. That many years old, and calc days old. Now notice here I'm calling the method that I just wrote. Here I'm accessing the field. Here I'm just calling a method. And that would avoid that problem of potentially creating some stale data. If I go back here, Jane Doe, 40 years old, and 14,600 days old. Okay, let me break that across multiple lines so you can see that. All right, so up next is I'm going to delete my notes and have you do a challenge. Okay, so again, all of this was just demonstration code. Actually, you can keep that. I'll just delete all this over here in the program.cs. Okay, and let's get the requirements on screen. Okay, so here's the challenge, and I'll offer one modification that you can optionally make. But let's go through. So we're going to create a cart class that represents a shopping cart in an e-commerce application. The cart class should have the following fields. So we're going to have a cart ID. You know, if it's just a number, obviously it could be an int. But sometimes IDs are like what are referred to as GUIDs, globally unique identifiers, and GUIDs have numbers and letters, and they could be more complex than just numbers 1, 2, 3, 4, 5. Okay, so you can make the cart ID a string, and you can have an items, and you could do something, the syntax like this. An items field, and that items is a dictionary, which we touched on dictionaries already, of type string in double, such as a lollipop that is $2.50. So you can look it up by its name, and the value that it has would then be the this would be the key. The lollipop would be the key, the name of it, and then the value would be $2.50. The cart should have the following methods: add item, remove item, get total. You can optionally add constructors or toString methods, and you can kind of again remember the purpose of those. The one modification I'll make here is you could potentially set items. If you want to make another class, you can make a cart item class, and so you'd have to create another class called a cart item class. Okay, but that would just again, so the cart item could have a string for the item name and a cost as well. I would start off by just doing a dictionary, but again, you could optionally make another class. But for this, let's just keep it here for now. Take 10 minutes, and I think we're ready for this challenge. Okay, so we're going to use one of Matt's solutions here to create the class. So we've got the cart class. Of course, we're going to right-click, add a class called cart. And Matt started off by declaring the fields. We'll go ahead and mark the classes public. So we got a string for the cart ID and a dictionary of items. Marked it as a nullable dictionary. And we have two constructors here. The default constructor and one constructor that takes in a string for the cart ID and initializes the dictionary basically as an empty dictionary with no items in it. And so it'll take a string for the ID and basically no items in the cart. Yes, Jamisha. You could, does not have to be. In this case, I think this is just being a little bit more explicit that this is an empty cart. You could, Oh, no, we do need this. I'm not sure if you do this, if this would actually work or not. Part of me wants to think yes, part of me wants to say no, but it's a good idea just to be explicit anyways, that this is empty items. Our add item takes in a string for the name of the item and a double for the price. We're then using the add method of the dictionary to add a new item. Remove item, it's going to be very similar, except for we're just removing it by its item name. So items.remove. Get total allows us to loop over our dictionary, our underscore items dictionary, and read key value pairs called item, and then make what's called an accumulator. Total is a local variable referred to as an accumulator that's going to accumulate every iteration through a loop a bigger value. So it's going to append the current item's value to the total and then loop through all of the items and then return that double data type. And a toString method where we print out one string. Basically, we're returning a string. We're building a string and we're returning that string. So again, you often hear the term string builder because it's just the strings getting built bigger and bigger and bigger. So you start off by printing out the card ID, then you loop through all the items, append that to the string, and then you append the total, and then return that string. And you can see the line breaks to kind of format that string appropriately. Now kind of going back here, we're going to instantiate a dictionary called items, adding some items to our dictionary. Now we actually, but this is not necessarily using the cart yet. We instantiate our cart called cart1. The cart ID is 1234. Actually, I don't think we wind up using that.
Yeah, I wasn't sure if I needed that or not.
Yeah, I don't think we wind up using that, which it could be if you wrote a constructor that could take that. But now we're adding a couple items to our cart1, and this implicitly calls the toString cart1. And it'll spit out our cart ID, the two items that are in there, and our total. We could call the cart1 add item and then spit it all out. Now let's do a cart1 dot remove item, and we remove gum, and then print out cart1 again, and just kind of see the cart is being updated as the program executes. So that's showing off the get total method is being called inside of toString. So we show off get total, we show off add item, we show off remove item, we show off the constructor, and voila, job well done. All right, if you wanted to show off the code reusability, right, we've created the blueprint, so might as well create a second cart. Sure, adding milk, bread, eggs, IntelliSense pretty savvy there, and then right line cart 2, right, reusing the logic from the cart class to instantiate. You could create, of course, you could create an array of carts or a list of carts at this point. But that's the basics there. All right, so we kept our person class intact, and that's good because I'm going to continue. We're going to talk a little bit about inheritance. now that we're kind of done with that challenge with the cart. Okay. And so moving on, the next topic to talk about is this concept of inheritance. And, obviously, most people understand inheritance in the real world in different ways. When it comes to the real world, you inherit things like your genes, right? Or, if you're fortunate enough, maybe you inherit something like some money. If your parents pass away eventually, maybe you inherit in some things like money or houses or whatever, cars, maybe. Okay, but inheritance, the point is things are passed down from parents to children, whether it's genes or whether it's real world things. That's the idea of inheritance, and it's in C# and object-oriented programming. Inheritance is always defined based on what things are. So a person, when you have inheritance relationship, you'll often hear that inheritance is referred to as an is-a relationship. Okay, because when you're defining things that inherit from other things, in the English language, we'll say that a student is a person and a teacher is a person. So there are different relationships in object-oriented programming. One big one is inheritance, and another big one is referred to as aggregation. Aggregation is a little bit different. I'm not going to focus on aggregation now because, we need to talk about inheritance at least first. Just for just for the basics. Now, aggregation, just as I brought it up, is referred to as a has-a relationship. So inheritance is based on what things are, whereas aggregation is referred to as a composition, what things are composed of. It's a has-a relationship. But let's focus on inheritance. So in C#, big thing here is that the colon represents inheritance. And you can inherit from one and only one parent. So there's your rules. So let's go ahead and make a class. Jester, you have a question? Yeah, one class will inherit from another class. That is correct. So notice I've got my person class. Now, person is going to be the parent class that we're going to inherit things from. Now, what things do we inherit? Well, first off, let's talk about, we need to do the actual syntax here of class inheriting from person. Okay, because we got the namespace here, we're already wired up to work with that little code. Okay? So all I have to do for a student is inherit from person, and it will inherit, student will inherit, I would write this differently, the non-private fields and methods of person. Okay? And so what exactly is this child inheriting from this parent? Well, we can inherit the accessors, the mutators, this calc days old. We can actually work with this toString method of the parent. That's why it's, anything that's non-private. So just then what's the benefit here? Number one, code reuse. Since I have a student, I don't have to code a way to set the student's first name or last name or set their age. Okay, so let me demonstrate public student. Okay, so this is the student constructor, the default. Let's look at this syntax. Notice my student will accept a first name, a last name, and an age. And then I can pass the first name, last name, and age up to the parent constructor. So base, this keyword base, says pass these three fields up to the parent constructor. The parent obviously being person. Now the way inheritance works is you inherit, as you go down a hierarchy, you go from generic classes that are parents to more specific classes. I always think of something like you can go from animal down to dog down to poodle. Okay? So the higher up the chain you are, the more generic things are. And the further down the inheritance hierarchy, the more specific things are. So the idea is that as you get to poodle, you know, poodle might have attributes that dog does not have, right? You know, dog has to be kept generic, like maybe a number of legs, you know, something like that. Whereas poodle might have the coarseness of their fur. I don't know, but more specific attributes to poodle, like maybe how, you know, maybe you rate how chill the poodle is, how calm the poodle is. You know, is it the vibe? Thank you, the vibe of the poodle. How much lapdog are you? 1 to 10. You know what I mean? Yes, thank you.
So basically, it's like file explorer.
It's kind of like you're going down a path. Yes, in File Explorer, it's almost like you're going down a little bit. You could think of it that way. But so the point that I want to make here is that student might have some specific attributes that a person might not have. Well, an easy one here would be grade. So I might define an instance field for a student, such as a grade, private, double GPA. Now, a person doesn't have a GPA, but a student does have a GPA because it's more specific. So I might accept this GPA in my constructor and initialize my GPA. So I don't have to recode. I get to reuse, you know, the naming, the last naming, and the age. All people have these fields, but unique to my student has a GPA. Right? So kind of going back here, just as a demonstration of this, okay, I could say student S1 is new student, and if I look at my overloaded constructor, it now takes a first name, last name, age, and GPA. Oops. First name, there it goes. Bob Evans is 40, and his GPA is 3.5, semicolon. So I got to reuse the person class because I inherited, right? So everything in object-oriented programming is all about code reuse. Why do you write a method? Code reuse. Why do you write a class? Code reuse. Why do you have inheritance? Code reuse. You're minimizing the duplicate code, right? You hear the acronym DRY. Don't repeat yourself. You hear that all the time. Okay? Now, again, in the constructor, this is how we might put the data in and pass those fields up to the parent. What about the toString? You can write an accessor just to get the GPA, but let's do a public, or an override, excuse me. Let's override a public toString method. Base.toString, just like over here, base calls the parent constructor. This would return the base toString plus their GPA is plus underscore GPA. Right? A little string concatenation. But this is going to get the first name, last name, and age. And then it's going to append this string to the end of that. So base is how you call the parent version of this toString method. And if I come back over here and I do a console.writeLine S1, that's going to call that toString method that we just wrote. Person name is Bob Evans, 40 years old, and their GPA is 3.5. Okay, so we could tell we're instantiating a student here because they have a GPA, which person does not have. One more tidbit on when it comes to inheritance. We inherit one rule here. In different languages do this differently. Single inheritance. Okay, meaning you can only have one parent. Single inheritance in C# means you can only have one parent. Not like the real world, we got two parents. Only one parent here. Yes. You're allowed to have multiple, yeah, so student might have a child underneath it, and that's totally fine. But that child just has one parent, which is student. Right? So, I mean, what would make sense underneath student? Maybe you have a certain kind of student that is a technical student, right? Technical student inherits from student, right? Versus a versus a university student, right? Different kind of schools, if you will. However, you can only have one parent. However, you can implement multiple interfaces. Oh goodness, here's a whole nother thing, is this interface. So we got this. Once you learn a little bit about inheritance, then it dovetails into, well, what is an interface? And again, different languages, I'm thinking of C++. C++ allows you to have multiple parents. Okay, why did C# get rid of that? In other languages, got rid of that. Because you start having conflicts. What if multiple parents, what if your two parents had the same method names? And you're inheriting from multiple parents, but those parents have the same method names. Now you've got some conflicts going on. You don't know which parent to inherit the method from because it doesn't know, right? So multiple inheritance, right, is not in C#. C# only has single inheritance. And it's a roundabout way of saying, well, you can still run into that problem because you can implement, if I can type right, implement. You can implement multiple interface. Well, what is an interface? What is an interface? So let's answer that question. Let me go to Solution Explorer. I'm going to right click. I'm going to add a new item. We're going to click on interface. Turns out it's just a different keyword. And an interface forces behaviors onto an object. Okay, what does that mean? It forces methods onto an object. Okay, so what behaviors might our students or teachers, maybe students and teachers, because I haven't created a teacher class yet. Maybe there's some shared methods that both of them need. And the example when I think of interfaces that always comes to mind, and I know I got a lot of gamers in here. League of Legends. You guys play League of Legends, right? And what are the is it QWERTY? And those are your abilities. Every champion in League of Legends, they have to have those abilities. An ability when you press Q, an ability when you press W. E-R, and is it T-Y all the way across?
It's like CF or something as well.
Okay. But here's my point. Every champion has those abilities. Now, they're different abilities, but
It's still an ability.
it's still an ability. Those are behaviors that are forced onto a champion class. Okay? So these are actions that are forced onto the class of champion in that case. So, I need an equivalent behavior list for students and teachers, and maybe, I don't know, so maybe I'm going to call this,
View grade.
yeah, something like that. I'm thinking course actions, like actions you can take on a course, something like viewing a view grade or starting class. Like, how would a teacher start class? How would a student start class? Those are actions that we both have to do. We both have to start class. We both have to end class. They might look differently. My action of starting class might look differently than your action of starting class. But nonetheless, we both need to start class. So I'm going to have course actions.cs. Now notice the keyword is just interface instead of class. That's the only difference. It's an interface. And an interface defines the methods that a class must implement. So you're forcing behaviors, right? Well, Mr. G, how is it really different than inheritance? Well, keep in mind, when you inherit methods and fields, all sorts of things there. This is only methods. We're not inheriting any fields. You're forcing behaviors here. So they're public and abstract by default. What does it mean when a method is abstract? It has no body. It's a method signature, but there's no body. So let me do public void, and I said start course. And I think that's all you need. So this is a behavior that if another class implements this interface, that class is going to be forced to write this method. It's going to be forced to implement the interface. Okay, and I'll just do another one called, stop. At the start of the course, you do these things. At the end of the course, you do those things. Okay, so these are just two methods. These methods have no bodies. There's no method body. It's just a method signature. And if I go back here on student, I can implement the course actions interface. So I have one parent that I'm inheriting properties and methods and fields from. And I can have many interfaces. And right here it says, wait a minute, you're supposed to implement this interface called start course and stop course. You need to put these methods in your class. Thankfully, you could just click Control Dot and implement the interface. And down here, it'll write the methods for you. And actually, this is where this will be where we actually put the method body. This is where we define how does a student start the course. And I don't know, console.writeLine. Student turns on PC, laptop, takes out notebook and pen and is wide awake and attentive. So this might be a behavior that we want to force our students to take. Single parent, and if you had another interface, complement here's my mistake that I made. It is convention for your interfaces to start with a capital I. So let me fix this, right? Course actions. Watch this. I'm going to right click, rename. We're going to call this I course actions and hit enter. And it'll rename it all the way across. So you have one parent and, if I say not that we're doing this, but I just want to show you the syntax. One parent, multiple interfaces. And again, when you go to show potential fixes, okay, I collection, and it would write in the copy, count property, all these other things. Okay, I'm not going to do that from this. Okay, I need to take a step back here. I need to take a step back because when we're talking about classes, okay, I'm going to make a new class. I've got my student class, and my student's a little bit more complex because we're inheriting. Let me make another class. And this is just demonstration purposes. I'm not going to work with people and students and teachers. I'm just going to demonstrate maybe a book class. Okay? So maybe this plays into our system, maybe it doesn't. I want everyone to kind of zone in for me a little bit because these next couple things are important. And you're going to use this all the time. In this class, you will use this all the time. Remember, we kind of started off by declaring our fields. And then we wrote accessors and mutators. If you would have a class, okay, like a student class in real world software, you might have 50 fields, 50 fields that belong to person. And for every field, there's basically two methods. There's an accessor and a mutator. And so somewhere along the line, someone said, we're writing a lot of source code, and it's not really, maybe there's a shorter syntax. Maybe there's a way not using methods. Let's make something called properties. And these properties are going to do the same things as the method, but the syntax is going to be shorter. Right? So if you remember properties look something like this. I'm just going to do number of pages. Private int num pages. Public int num pages. Remember these?
Yep, getters and setters.
There's get blocks and set blocks. This is referred to as a C# property. It puts the get block in the set block. And you would all agree that this syntax is much shorter. Okay? So that was iteration number one. Let's talk about the evolution, right? It started off with accessor and mutator methods. And they say, wait a minute, can't we make this a shorter syntax? Let's make this thing called a property. Okay, now if I were to instantiate this book, we go back to program CS. Okay, book B1 is new book. Default constructor B1 dot, what do I call it? Num pages equals 100. This book has 100 pages. Console write line B1 dot num pages. Okay, put data into the property, pull data out of the property, run it. And it's just going to print the number 100, nothing crazy. Okay? But we've effectively replaced accessors and mutators methods. We've replaced these methods, longer hand syntax, with the shorter hand syntax, with these things called properties. Even this, someone decided this was too clunky. Let's make it shorter. Let's make it shorter. So you know how they replace this? they do. So this was just called a regular C# property. Okay? So they came out, I don't know, 10 years ago, and they made something called an auto-implemented property. There's a mistake that every newbie makes on this one. Okay? If I'm going to replace num pages with an auto-implemented property, it looks like this. It looks public int num pages. You guys remember auto-implemented properties? In fact, I'm willing to bet most of you only remember auto-implemented properties because they were so condensed. You probably used these over the other options that you had.
I remember both.
You remember both?
Yeah. I remember there was some cases where we had to use the normal properties.
Yeah. So what are those cases where you have to use?
I think it was like whenever you don't want to do a set, you only want to.
If you want to read only, well, you can do that. You could do like you could just do a read only. You could do a read only auto-implemented property. But
or I think it was when I was like interacting with other properties.
You're getting, that's what it is.
Yeah.
When there are more specific things you need to do than just access and modify the data directly, when there's more complex rules around accessing and modifying the data, like maybe you have a rule, like let's just say salary, and salary cannot be less than 40,000, it cannot be greater than 100. Okay, there's some business logic that has to be spelled out about salary. You cannot use auto-implemented property in that case because you have to write more C# logic for those business rules. Okay, but yeah, these auto-implemented properties, very common. Here's the mistake that newbies make. Newbies still want to create the backing field. This underscore num pages is called a backing field. It is behind the property. When you use auto-implemented properties, you no longer create the backing field. It is created for you automatically. Yeah.
Maybe it's movie. I just like seeing it. I don't know.
I know. Well, it is normal. You like understanding it, but I'm just.
It just helps me understand.
It does. It kind of helps to understand. But what I'm saying is, if you create underscore num pages, and you try and use it, you're going to encounter some errors.
I tried making a comment for a reminder, and it auto-filled to just put it as C# will create the private field for you.
Yeah, C# will create. Well, there it is. The compiler will create a private field for you. Was that your question or something to do with that, Jamisha? Yeah, where do you find it? I think it's. I don't think you find it. I don't know how to physically see it. If you can find out where to physically see it, I don't know. That would be cool to see, but there is no seeing. But this code now still works, right? So again, it's important to note, when do you use auto-implemented properties? If all you have to do is put data directly in, no business rules around the data, and pull data out, you can use an auto-implemented property. But if your data is more complex than that, if you have like, if the salary is too low, don't put it in. Else, if the salary is too high, don't put the data in. Then when you have business rules around the data that govern the validity of data validity, then you need old school properties or old school accessors and mutators. Okay, so like kind of even going back here, we could go down here, and when we're putting the GPA in, we can write some logic here. We could say if GPA is less than or higher than this range, I want you to throw an exception or raise a flag and say there's a problem here. There's a problem here. This could be done different ways, but the point is now we have some business rules around GPA. And so you would not use auto-implemented properties for GPAs. Okay. So, so those are the different ways. It's also worth saying you could do something like this. and this is a way of initializing a different default. So if I were to go back to here and just comment out the num pages, you could see there is now a default value for our auto implemented properties. So you see this, and again, is it nullable? You see this. Like this line of code, very common in this class. This kind of line of code. Because obviously it's not exactly that. So, you know, believe it or not, a lot of this stuff that we're doing right now, we're going to use all the time in this class moving forward. Specifically, one thing I want to hit on a little bit more is this idea of an interface, because you see this a little bit. So we never spun up a project 9, so let's spin up a project 9. And when you have interfaces, you get this thing called polymorphism. And if you've ever heard that term before, it's definitely like an easy one to throw out in the OOP space. Like, can you explain polymorphism on an interview? And you should be able to. But I think, like anything, doing it will help you learn it. So let's spin up a new project, Council App, Proj 9, and we're going to talk about polymorphism here, and specifically interfaces and how they all play nice together. So let me close everything that isn't Proj 9 Program CS, and let me set that to my startup. Okay. So I'm going to do a little code demo, and again, after this, you'll have a challenge. Okay? And it's going to be pretty doggone similar. All right? So I'm going to start off by making some classes. And these are going to be really simple. A patient class, like a doctor patient. Okay, so let's bring in a using statement there. Okay, I'm going to have a patient. I'm going to have a football player class. I don't even know if I can pronounce it. Upholsterer? Upholsterer?
I think that's right.
Okay, I'm kind of following a little example here, but and I'm going to make an interface. Add an interface that all of these classes are going to implement. So add a new item, click on interface. The interface is called iRecoverable. Okay. And we're going to have one method called recover. It's going to return string. Now you don't have the access modifier here. Okay. So again, an interface is all about forcing behaviors onto a class. So a patient can implement iRecoverable. Now, again, depending on if this is an interface or a class, you can only inherit from one class, but you can implement multiple interfaces. You can hit Control Dot right here and enter, and it will spit out this method signature. And we're just going to change this to return the patient is recovered. Whatever, in the doctor's office. So a patient is going to recover differently than a football player. But we want to force the recover behavior on the football player. We're going to hit Control-Enter, and we're going to return a string. The football player is recovering in the locker room. What's the question?
What did you have the patient like that return?
The patient just said recovering in the doctor's office. The football player recovers in the locker room. Control dot, implement the interface. I wonder what. Okay. The actual string doesn't make the biggest. They recover differently. And that's the point worth making. Okay.
I can remember Mr. G's example of this now. With animals is what he used.
Uh-huh. So now we're over here in Program CS, and we can create patients. P1 is new patient. We could say football player, person 2 is new football player, upholster, okay. Now, I'm going to write a method called recover. Okay. I'm writing a method that I plan on reusing. Okay, now, does the name here, it's, you could call this method whatever you want. I happen to give it the same, I call it recovery just to, nope, that's not right. Over here, call this one something different if you want to, because that point doesn't necessarily matter. The interesting thing here is line 7. Line 7, we say that this method accepts the data type of iRecoverable. Again, you will see this in this class. And then the identifier is just the letter R. And so the rule here is that any class that implements this interface, an object of that class can be passed into this method. So what we have here on line 9, well, what does line 9 do? Line 9 is going to have a different result based on the object that's passed into it. That is the definition of polymorphism. Polymorphism states that a method method's behavior will change based on the object, not that calls it, that it references. Okay? So take that in for a second, right? Because line 11, if you're just looking at line 11, everyone look at line 11 for me. And if you're looking at line 11, and that's all you're looking at, you might think as a programmer, line 11 is going to do the same thing every time. You might think that line 11 is going to have the same behavior every single time. And in this case, that's just not true. Line 11 will do different things based on the object that R is. If R is a patient, it's going to do one thing. If R is a football player, it does something else. If R is a upholsterer, it does something else. And so what I can do here is I can call recovery and I can pass it P1. right? This is just a local method. I'm calling line 11 right here. And since P1 is a patient, we're going to get the patient is recovering in the doctor's office, right? But if I pass P2, save and relaunch, you're going to get a different behavior. So this is really interesting to me when I learned this. Any class that implements iRecoverable can be passed in. It is a valid data type to pass in any class that implements that interface. Does that make sense? Do you guys kind of remember this from before, or not so much, maybe a little bit?
I don't think we.
If you did those labs, you did this probably once, but again, it's easy to, just one time isn't enough.
Yeah, we just like
Didn't focus too much on it. Yeah.
we did like animal, dog, and cat.
Yeah.
It's like the animal makes a noise, the dog barks, the cat meows. That's about all we did.
Yeah. But this just this right here, this idea that a data type inside of a method can be an interface, it's like, what do you even pass into that? And it's like, well, whatever implements that interface is a valid argument to go into that parameter. Right? So just even learning that piece is like, huh. And then learning that, well, that line of code can produce different results based on the data type of R. In this case, R is a P2. P2 is a football player. So this allows you to kind of write some flexible methods, and this, you can do something like void, whatever, do, foo, object O, and then literally any class can be passed into object. So this is a little bit different. This says line 11 says any class that implements this interface is a valid argument. This line 16, this is different because any child of the data type object can be passed in. Well, guess what? All the classes that we write, object is the parent of everything, right? I think of the object class as the great grandparent. It's the starter of them all, right? If you believe in, religion, this is, Adam and Eve. I think I was thinking, was it? I didn't know. Okay, whatever. Okay? But the point is, there was no one before them, right? I don't know if my comparison really lands there, but it doesn't matter. Object is the parent of all other classes. So any child could be passed into object. And so I could pass any one of these. I could pass foo. And then, come on now. I'm going to call the method foo. I'm going to pass P3. And P3 can be passed into foo. Why? Because P3 is an upholster. Control click upholster is a class. Class implements, inherits from object. There's an implicit object here. Like you don't have to type that. That happens automatically. Yeah.
So if you were to have you have a list of a data type of an interface and just throw in a bunch of different stuff that's all inherited from that?
Can you have ask it one more time, I'm sorry.
So you know how you have to define a data type for lists to put stuff into it?
Oh,
Define
yeah.
as a data type and just throw in everything that inherits it?
Or like an object, a list of type object.
Right, okay.
What's it's so generic though. It's like you're almost getting into JavaScript land where you just put whatever you want into it. You know what I mean? So if you can get more specific, you should. But I've seen this before for sure, where it's like, write a method that takes type object. Yeah, you can make a method that takes a list of object, and then any C# lists, a list of ints, a list of, you know. Okay. Let's write, here's a challenge, right? So this is our challenge for number 9. Okay, so here's the challenge for 9. Create an application with 4 classes: page, corner, pancake, and leaf. Create an interface named iTurnable with one method called turn. The 4 classes should implement that interface with a different implementation of the turn method. In program, write a method that accepts, in program CS, create a list of iTurnable. So this is interesting. Remember, any class that implements that interface is a valid data type of a list of iTurnable. So since, for example, page implements iTurnable, you could store a page class in the list of iTurnable. Same thing, you could store an instance of corner in this list. You could store an instance of pancake in this list. Okay, then write a single method that accepts that list, calls the turn method on each item in the list. Yeah, the turn method, you get to, how do you turn a leaf? It's just returning a string, right? How do you turn a pancake? How do you turn a corner? How do you turn these different things? Whatever string that returns is fine.
You want me to post like
Yeah, sure. If you want to maybe post in the chat, Paul, we'll go through your solution. Closing everything that is not this. Cancel. Close all but this. Close other tabs. There we go. Okay, so we're going to start off with the interface. Called iTurnable. And all we do on the interface is the method header. The method header is the method name, method signature, and the return data type here. So there's our interface. We're going to implement some new classes. Add a class called leaf. Pancake. Corner. We got page, that's the last one. All right, our page implements iTurnable and returns a description, returns a string for turning a page. Corner. Same idea. Pancake. And leaf. Okay, all 4 classes implement our interface, which allows us to, in the main method, instantiate our classes. This is a syntax, and thanks Paul for showing this up. It infers the data type when you just say new semicolon. So this is a shorthand for that. Even the new expression can be simplified. So if you followed IntelliSense, it gave you that syntax. Now we create a list of iturnable. And this was Paul's implementation, because a list behind the scenes really is an array. Another syntax for that is just the same. Okay, so we have a list. We're adding our 4 objects into that list, and because these 4 objects implement the interface, the data type, this works, right? If page did not implement the interface, or leaf, for example, didn't do this, all of a sudden, that doesn't compile. And here's the method. Let's save that. Okay. Here's the method called turning, where we're looping through the variable that's passed into the method. The identifier here is called T. So this is a list of turnable just called T. We're looping through for each iturnable. Here's our object. We identified it as turn, and we say turn is our identifier.turn method. And then we call that method, passing the turnables. There's like a tongue twister on this.
Turnable.
That's right. And there we go. Very cool. Good job. All right. We're running out of class time, so that's probably the last. That will be the last project, Proj 9, for the lab. Project 9 was what we would call the turning objects, whatever we call it. So 2 things that are left to talk about. One's a lot easier than the other. Is debugging. And so in C# we learned these tools. You know, in JavaScript debugging, a lot of times we were just used to what we were doing is we were doing console write lines. We were doing we had the debug package, and we were doing all sorts of debugging write line statements to kind of trace our variables. So in JavaScript we were doing a whole lot of tracing. Because it was kind of hard to stop the execution of the program once you kind of sent it off the server and the client received it. You know, it was hard to actually implement a breakpoint. Now you could implement a breakpoint on the client side, and so there still were breakpoints, but nonetheless, breakpoints here. We've been starting without debugging, and I just want to show the controls that you guys will find useful, and we start with debugging. So this is just F5 instead of Control F5, and then you're left with these controls here to navigate your code. You can step into, which is kind of what you do by default. If there's a method that you don't want to step into, you can step over. So you can kind of see here, we're going into our loop. Now we're executing line 24. Now we're going to call line 25. Obviously, line 25, we step into, because the first thing we're returning is a leaf. We're returning that statement and printing that to the console. If I were to pop that open, you could see it wrote just that one line. And so breakpoints are, when it comes to troubleshooting, your best friend. Being able to debug problems, will separate beginners from intermediate developers who are able to use these tools and solve problems with them. And so that's nice, but maybe after so many, maybe you want to kind of step over and you don't want to step into it anymore. So you can see stepping over versus stepping into, kind of the difference there. And once you're done, maybe you're done with this iteration, we can hit continue. So that's just a real quick, dirty. Now, there's some other windows worth paying attention to. If I start that up again, you can see some other windows down here where you can inspect your variables while this is executing. And so you could see T sub 0 is a leaf, sub 1 is a pancake, sub 2 is a corner, sub 3 is a page. So you have these different windows down here that show different scopes. And like if I want to watch a variable X, obviously X doesn't exist in the current context, but these windows, autos is different than locals, because locals is literally the local method, whereas autos might be a few more or a different scope than locals. But yeah, having these watch windows, local windows, and autos autos will help you trace your variables while the program is executing. Those are very beneficial. There are also conditional breakpoints, which are really cool. So like if this loop were executing 100 times, you might not want it to break immediately. You might want it to break on the 50th iteration. So you can go into a breakpoint and set up conditions and say, hey, I only want you to break when X is equal to 5. And so that symbol changes, and now you might not have to step through 1,000 lines of loop, to get this loop to maybe break towards the end of the execution. So there's conditional breakpoints, and you could put breakpoints at multiple points, which means if you do have this, let's see, you could break here and you could break here. I don't do too much of this because I think, but you can. You say, okay, I'm looking, okay, I'm good. Now I'm going to hit continue, and it's going to run until it hits the next breakpoint. So you don't have to like step through every line if you use continue. If you hit continue again, there's no more breakpoints to hit, so it just runs the rest of it. And then the last thing to talk about is try catches. Try catch block. Okay. So I just let IntelliSense kind of write some code for me. But the main thing I want to talk about try catches before we're finished. You can have multiple catch blocks that can catch different. Notice here, we're expecting line 25 to throw an exception. Zone in for me, guys. I know it's the end of class, but I want to talk about this just a little bit before we're done and why these are important. A little bit of theory before we're done. Try catch is an object-oriented programming concept that allows you to handle errors in I would just say a different way than default error handling. What do you mean handle errors in a different way? Well, if you have an array of ints, okay, and there's two integers, and you were to do something like my ints sub 2, this is going to crash. Why is that going to crash? That's going to crash because the valid indexes are 0 and 1. There is no sub 2 here. There's two elements. Their indexes are element 0 and element 1. And so in a traditional sense, you know, and maybe you ask the user, you know, console.writeLine enter a number, int num equals, okay, get the read line, and then we put num here. Okay, so obviously this makes a little bit more sense, and then we're accepting input from the user. Hey, give me the index. In other words, what position should we enter this into? Now this is very likely to crash, okay, because we only have two positions, and if they enter anything besides 0 or 1, that's going to cause this to crash. Well, you might do, in traditional error handling, you might do something like if number is greater than 1, or better yet, I would just say do while, do this while num is less than 0. I like that. Num less than 0 or num is greater than 1. We got to change our scope here. Int num, okay, semicolon. Okay, now I've written a do while loop that is traditional error handling. You're very manually checking to make sure that the user's not going to give you a number that's going to crash the program. And there are software projects out here that do nothing but traditional error handling. They do not do the object-oriented approach of solving this. Okay? I remember we were talking the other day, just even in this class, and someone said, yeah, you know, I know someone who wrote software for USPS. I think that was a conversation happening in here. And I knew a developer who worked for USPS, and he said, Mr. G, you know, Evan, we don't write try catches in our software. We do everything kind of the old school way, using if statements and do while loops and for loops, whatever. Okay, so first off, you know, this is an object-oriented approach for handling errors. There's multiple ways to handle errors. There's kind of the old approach, and then there's a newer approach with try catches. So how would you write this in a newer approach besides like a do while? Let's go ahead and get rid of our do while. Let's just accept whatever the user gives us. Now, I would expect line 35 to potentially cause a problem. I'd put that in a try block. So you put the potential, and I'm going to catch an argument out of range, exception. Okay. Now this is going to give me an error message because this is the class argument out of range exception, E, and this is just going to give an error message to the user saying, hey, that number is out of the range. Okay, and I have got another catch block that's kind of a catch-all. Remember, exception is the parent for all other exception classes. So this is a parent of all other. So I don't even know, but let's run this. It should ask me for a number, and I give it 6, and I get index was outside the bounds of the array. Okay, that message right there this message right there, if you don't do this try catch, okay, if you don't have this try catch, watch what happens. What happened last time is that our program terminated properly. What happens this time, number one, our program crashes. Okay, it crashes and gives an even uglier message, which includes like all this about the call stack, line 55, line 32 are causing these problems. So this is an unhandled exception. This exception was never handled. It gives all this ugly exception messages, and the program does not complete correctly, right? The program that Paul wrote where we're actually calling this method, if I bring my try catch back in, okay, not only does it give a somewhat more friendly error message without all the call stack gibberish that doesn't make sense to anybody besides a developer, but it does also finish the program, right? So again, there's multiple ways to handle errors. There's there's all the loops and if statements that are called traditional, and then there's a newer approach called structured exception handling, where you've got try and catch blocks. Okay, now when do you use each? Like, what's the recommendation? Because you could just use one or the other, but the general rule of thumb is that if the error itself is expected to happen with high frequency, do not use try catch. Exceptions, literally in the name of the thing, should happen exceptionally, right? So the rule of thumb that I've always followed is if I expect this error to happen like 1 in 10 times, 1 time out of 10, you might put it in a try catch block, okay? Because I'll give you a little bit of my experience here. I've been around long enough. I've worked on some old computers, and I've seen try catches perform very slowly, right? So now on these fast computers nowadays, we don't have that problem as much, but I've literally seen software slow down because of the try catches that have been written. Okay, so do loops and if statements are much more performant, I would say, than structured exception handling. But there are conditions where you got to use this. Okay, and so you're doing database calls, and it becomes very hard to not use these try catch blocks in some situations. Okay, so that concludes the crash course. Yes, we got a question.
Not really a question. I'm just saying how I remember using try catches and like normal error handling in the other C# class.
Yeah.
I would always manually handle errors myself of anything I could think of, and then use exceptions as a security blanket.
Yeah. Yeah.
Sort of.
Yeah, as a security blanket to keep your program from crashing.
Yeah.
Right. It also depends on the software too. I would argue, like a piece of software that's monitoring patients' lives, like you got to keep that up and running.
Yeah.
Like you can't let that crash. Other, like your Microsoft Word homework file might not be as important to keep running. You might just let it crash and reboot. Okay. Have a good day, everybody. Tomorrow, I'll stop the recording here.